All right, here we are. Welcome to stream. do, do, do. Don't even bother. Straight up. I like that sample. That's a good old bother sample. Straight up and down, don't even bother. All right, it's warm in here. I have to move the fan in a little bit. My Node Red stuff failed. What the hell happened? It didn't work. The light didn't come on. Nothing happened. I opened up OBS. Nothing happened. So what the heck's going on here? I put up a couple test flows just for starting stream though. So now I've got all this data here. I'm going to cut and paste into a... Copy that. We'll put it in Notepad. I have all this debug stuff from ahead of and behind the stream state change. So now I can look at it in a controlled environment. So those are from today. Debug 1, stream state changed. Output active false. Output state, OBS WebSocket output starting. So if I can take this JSON and I can make that into its own trigger, its own little inject, and we can do message payload JSON, this, get rid of message topic. Done. Now this I can inject into here instead of stream state changed, and we can do more testing. And that should hopefully resemble the right thing. Don't worry about chat being blank. It's not active right now. Oh, let me get YouTube chat up. YouTube. Twitch TV, oh bother. Straight open. No, YouTube, oh bother VOD. There we go. There it is. There's my stream. I'm streaming right now. Yes. There's double audio. Kill that. And then pop out the chat. Pop out chat. I wish I could automate that. I don't know how to do that. I don't know how I'd be able to go into my stream, whatever stream is active, and then choose the pop out option for chat. I mean, honestly, YouTube really should provide me with a fixed link to get to my chat. And maybe I just need to Google that a little bit and figure it out. I cracked the window, but the cold air hasn't come in yet. Of course, we're going to be looking at test equipment today. We're not going to be doing the Node Red stuff, but this is just my extracurricular activity to try to get this indicator light functioning at all. This thing is powered on, right? Yeah, it's powered on. And I've got all these debug messages over here. I've got an influx of debugs. What's up, Svar? Output starting. Invalid message received on input. What does that mean? Is that contains invalid message into here? Message.payload.output state. That's what I'm hoping to get to. I thought that would access the right part of the message, because we're looking for output state and we're looking for it to contain OBS WebSocket output starting. I like this album. This is a good album. This is Aesop Rock. Okay, what didn't I do yet? Oh, the message for the end of stream I need to do. Where's Discord? Take Discord, take my admin channel, copy this Mamba Jamba, copy, paste, and then give it tomorrow's date, which is the 31st. This month will not die. This month is hanging on for dear life. So the part that I don't understand is I've set it to message.payload.output state, and I believe that when the message comes in and it looks like this little guy right here, output active false, output state OBS WebSocket starting. Like that's how JSON works, right? So output state, message.payload.output state. What if I do, node read message contains. Flows by passing messages between modes. Messages are simple JavaScript objects of any set of properties. Messages have a payload property. This is the default property that most nodes will work with. Node-RED also has a property called message ID. It's an identifier for the message. Gee, you know, they're even thinking about this in baseline Node-RED, and Twitch API can't assign a unique transaction ID for when an actual payment is coming in. So I have no control over the API. This is a rant for another day. This is a rant that's totally unrelated, but it just annoys me with regularity. This annoys me that when you guys spend money on Twitch, I don't get a unique ID. But when you redeem fart points with the channel point system, that gets a unique ID, so that I don't have colliding things happening. You guys can confuse anything that I can code and get multiple names on the board because there's no transaction ID. I have to assign one. Using Node-RED with Twitch API? Not today, but yes, I will be very soon. Right now, I need to learn how to work with this crap. Object A and B. So I guess it's an object. Object string array. So this song is great with lyrics. This song, it's about whether or not there's a trap. Sounds like something somebody would say if there was a trap. Copies the path of the desired element. I got Twitch notification the minute you went live, and I waited to see how YouTube would respond, and no notification. I'm having troubles with other channels. That's annoying. It's always the case. There's always something. Something's always kind of a little bit awry when it comes to notifications and streams. You hear no end of it as a streamer. I need this to be on camera because this is the subject of today's stream, but I guess it would have to be on the big camera. I'll just put it like kind of over like this. Then my shoulder's going to get in the way, yeah. No, so I got to move. All right, let's do that. Let's do that. Twitch TV, oh bother. There it is. Okay, so you are not the only one that this is occurring to with. Yeah, it's always a mess. Everything's always a mess. Okay, so I'm learning how to parse JSON, even though I am a de facto expert in it from working with JSON on Burn the Subs. Literally have to manually dig down to the actual channel page and find the status of the broadcast. That's why I don't get a lot of YouTube views, I guess. The algorithm is not too favorable about me. It loved me when I was doing daily uploads of 5-hour videos, but that was a huge stress on me, and eventually I'll come back to it. I use Node JavaScript with home automation. I think this is a wonderful way to give your automation a brain. They say automate your home with all these tools, and all these tools are not that they're all meant for specifically automating things at your home. What's up, Uncertified Electrician? How's it going? That's a great Twitch name. It's a really good one. I want to get that on my board when we finish it. The thing is, like, Node-RED is not meant to be home automation. It's meant to be sort of an easy way to program Java flows, and it's great, right? It's like not meant for home automation, but it works as that because your home can actually be smart with it, as opposed to a software package that is meant to automate things at home. They might not think of all of the use cases that you have for such a thing, which is where Node-RED is really good, because it's not intrinsically that. It's meant to do a lot of other stuff. It's basically a lot of good. Yeah, that's exactly what I think. You guys, as far as you might have had a large say in pointing me in the direction that I'm in, because it's Node JavaScript, MQTT. I don't use Telegram API though, but I'm using a Mosquito MQTT instance on my file server now. It's on the file server. The file server is king, but then I'm going to have to access the REST API, which is what the file server speaks, in order to get statuses from it. And that's where this status light project comes in. This is whimsically, this bulb 1 here is going to be my on-air light. So it'll give me the status of stream. I'll also have another light that will do the status of maybe the status of the automation stuff in here. And then another one will be hard drive status, very specifically for the server. Just so I absolutely know that everything's okay in the server. And every now and then I'll have to have them like fade in and out a little bit and give just like an indication that they're not dead. Just so I know they're active. So, shows the contents property for arrays and objects. Copies path, copies value, pins the selected. Don't worry about, I'm not worried about that. JSON is a standard way of representing JavaScript object as a string. It is commonly used in web APIs. I'm aware of this. Node-RED provides JSON node to the convention. Common task flows to modify the properties of a message. For example, the result of an HTTPS request. Two main nodes, message functions, change node. So I'm wondering, flow string, Boolean, JSON buffer. Set operation, you can set the payload, message payload dot. So I am doing this right. Held in message payload temperature. So like, this is coming into the flow. And message.payload object. The object is output active or output state. And so I'm pointing it to output state, the object, and I'm seeing if it equals OBS WebSocket output starting. What's up, Ryan Labs? How you doing? So there's no reason why this shouldn't work right now. How is this wrong? How did I go wrong? Where did this all go wrong? Message payload output state, and the message coming in as read by my debug. Stream status changed. Message.payload. Output active. Output state. And I'm getting output state. I don't need the colon in there. The colon is part of the whatever it is. So I'm then looking to see whether it contains message flow global string, number expression, environmental variable, or previous value. In this case, it contains string, OBS WebSocket starting. Do I need quotes? Maybe if I put it in quotes. We'll try that. Probably shouldn't do this for all of them because it takes too much time, but doesn't need to be in quotes. Done. Deploy. Confirm. Inject. Nothing. So what do my debug get down here? Huh? Oh, did I give it the right message over here? Output started, and we're injecting. Oh, started. So if I actually change this one to debug started, or starting, it should go orang. Right, starting. Yeah, starting is orange. Deploy, firm, go. Syntax error. Unexpected token O in JSON at position 2. What does that even mean? Oh, I don't need to copy that. So it's here. Oh, do I get rid of the brackets? I don't think so. Nope, same thing. What the heck? How's it going, everybody? I'm trying to figure out some of this debugging stuff where I'm trying to inject a signal in here and get some kind of an output from my parser. I mean, when it changed the stream output, our debug got this object, output active false, output state, OBS WebSocket output starting is a string. So it's a true false and a string. Hi Lab, how's it going? I didn't even say your name yet. I'm trying to learn. I'm trying to learn things. What I'm trying to do is I'm trying to inject JSON, the JSON message that we received at the beginning of stream, output starting, so that I don't have to start and stop stream in order to test this. So I tried to inject that, and I'm getting a syntax error. Unexpected token 0 or token O in JSON at position 2. Red triangle equals bad. Oh, yeah. Okay, I see that. So message.payload as a JSON. Does it need to be an expression? No. No, it should be JSON. What's wrong with it then? Curly brackets, output active false, output state. 3 small dots to the right of the input box. Ah, okay. Oh, I see. Wait, no, that's in here. Okay, yeah. These. Oh, so it really kind of hates. Okay. How do I operate this? Do I have to do it like this? With, well, quotes around the whole thing? Did that do it? No, it still hates it. Okay. So you're saying, oops, not this one. Hold on. Actually, wait, can I copy? I can copy that and just directly paste it? No, it's the same thing. Same thing as before. Oh, that one recognized it. Is that correctly valued? I think it is, actually. I think that's correctly formatted now. But it didn't edit anything. Oh, what's the... Wait, there's now a quote on the inside of the curly brace. Oh, and no more... Okay, so if I had copied it directly from this, then it basically, it needs to key off of the quotes in there. That would be... I just want to look at it again. So quote around output active, colon, and then the Boolean, then a quote around the string that defines what the key is. Okay, so now that that's properly formatted, go down to the bottom of my debug, I inject it. Didn't get any errors down here, but I also didn't get anything over here. So what now needs to happen in this? So we are looking at message.payload.output state. And over here we have output active and output state. So output state contains the string. And I put quotes on it, but I guess we probably don't need quotes. Because that's the string. It's already defined as a string. I can make it a string object and put it in quotes, but I guess maybe this doesn't need quotes. No quotes in there. It knows it's a string. Okay, yeah, because I'm defining it by the pull-down menu. So no quotes in here. Why is this so difficult? It's so difficult. It doesn't have to be. If I had known things, it wouldn't have been difficult. So like that, and now I inject it and don't get anything on my debug. I'm going to clear the log. So I am not getting starting. And we're looking at starting over here. I can get rid of this one. Oh, did I not? Well, I didn't change anything of note. Get rid of this one because we're not doing that. No. U to U. Yeah, let's deploy and try it. Oh, And that's, well, that's supposed to be orange, but that's really not orange. It's not, that's like a light red. Yeah, removing the quote was enough of a change. Okay, so that appears to be somewhat working. And so if I, well, right now, I don't think I have the option of injecting the current state in order to get red. If I inject, I can do OBS output start ed. I can actually read, let's do started, and then we'll add another injection. Stopped. Oops. S-top. Done. Okay. Because I don't know how to get that property from stream state changed is already a changed dialog. I can't like put a timed thing inside of it. So let's deploy that. And then if I start, we go red, stopped, we go green. Okay, so that works. That now works. The rest of my flow works. Right now it's green, which would mean stream has stopped. But if stream is going, then we get red. This is a weird red on camera. Holy crap. That's a weird red. But now this should give us the status of the stream. Now the only thing that I need now, just for the theory, to save the current state, you would use a change node to set a flow property to the current value when it comes in, and then you can use another change node with an inject before it to retrieve the value again. All right, let me see here. To save the current state, use a change node to set a flow property to the current value when it comes in. So set this to the current value. Then you can use another change node with an inject before it to retrieve that same value. So I'm not sure I understand, but I know this relates very directly to what I'm trying to do next. What I'm trying to do next is to look at whether or not my OBS window is open. Because if the OBS window is open, I want this to display, but if it's closed, I want it to turn off this light. So the light's not always illuminated. And then maybe at some point I want to build in something to like fade do like a breathing thing every now and then with the light. So if I get if the inclination strikes me to look at the light to see whether or not I'm connected, still it'll do something every now and then that won't be completely distracting. That's the theory. That's the theory. Although I could just have this turn on like with the other set of LEDs. I could have it be very dim with the other set of LEDs. That could also work. But so OBS connection, so the problem with this one is OBS connection status, and let me just do contains opened. Just to show you what happens. And I could actually use the true false that this thing returns instead. But let's say if it contains opened, I'm going to turn the light off, right? So if I deploy this, what will happen is the light will turn off, but then every time it checks, which is kind of periodically, this will suddenly flash red. And of course, it's turning me into a liar right now. This thing is like, by the way, Obother is a liar. He's just straight up a liar. Oh, come on. It was doing it before. When I closed OBS, this thing was flashing. Every time it gets a signal, it does a little red bloop. So what I was thinking is I could do a status has changed kind of loop, kind of what you described. But I would have to like set a variable or something. I haven't figured it out. I think you're probably telling me exactly how to do that. This one. Well, this thing's turning me into a liar. I swear this thing was flashing. You can simulate a disconnect by going into OBS, opening the tools, WebSocket settings, and clicking the kick button on connection. All right. Well, let's turn on the normal flow then. We'll turn on the normal flow here, deploy that. So OBS connection status contains closed, turns it off. So if stream started, bada bing, we're red. If it stopped, we would be green. And then when I close OBS, I have to go into settings here. Hold on. Tools, WebSocket server settings, and then I can do OBS, opening the tools, WebSocket settings, clicking the kick button on the connection. Kick button. Oh, kick. Bonk. So that turns off. Now it just reconnected. But this was flashing red. It's crazy how much technology has complicated a light bulb. This is an indicator. This is a multi-status indicator. It's an RGB multi-status indicator. How dare you call it a light bulb? Even though I call it bulb one. So, okay, it's not flashing right now. Well, the WebSocket reconnected too, so I'm not sure if when I close OBS, if that's gonna blip. So I may need to build in a blip preventer on this thing. Oh, I'm so glad that this kind of fixed all the flows. Thank you, Leb. This is also one of my favorite songs on the album, with the skateboarding skeleton. This one's straight up just a toggle. So if I toggle it off, I'm seeing if it'll, I don't think it'll keep flashing, because it's actually the OBS connection state is going to go to contained open, and then it'll go to off. So if I do that and deploy that, see if that causes it to flash, if it blips. Because that's what it was doing before. I'm trying to prevent that. And on some flows, they have a little checkbox where you check if it's changed, but I don't know if this is a... These don't have that. Yeah, I guess they don't. I don't know why I was doing that before. Maybe because the connection has been identified, and if it's not identified, it keeps trying to connect, and that status keeps changing. So if I closed OBS, then it would have troubles connecting, and it would go crazy. What's up, YadoCat? How you doing? How you doing this fine day? Maybe I'll do like a... Well, what contains opened would be just that it's connected to this. This would override it, but then this would also recheck and cause the flow to happen again. So if I actually took this and I made like, what's another, like purple. If I made that status purple, I wired that up to the light, and I deploy that. Now this thing is purple, but if stream starts and it goes red, I think this will overwrite it. Yeah, what I'm trying to do is the WebSocket reconnected just fine. This was causing the light to flash red very briefly, which just means it received a command, which means that contains closed, like this connection status kept trying to find OBS, and it wasn't finding OBS, and every time it didn't find OBS, it sent out connection closed, and then that caused this thing to blip. For instance, like if I hit the toggle right now for off, it turns off, and then if I hit it again, there's a brief little red blip. So I need to prevent it from sending repetitious signals. It turns out this is actually okay what I have here, because it'll send contains opened only once, and then it'll get overwritten by started. And if I go to the WebSocket tools over here, WebSocket server settings, and I click kick, well, it flashed, it got something, but it didn't. Oh, now it's purple. So it contained closed that it turned off, and then it contained open and it turned purple, and it's not flashing red. And if I hit stream starts, it goes red, and then when I stop stream, it says, you're good, you stopped stream. And then when I close OBS, I'm going to simulate that by hitting kick, it'll turn off. And then, boop, stream's open, stream started. OBS is open, stream started. So that, I mean, I guess that's okay. The only thing that might happen is when I stop stream today, it's going to continue to pull this, and then my light will be flashing red periodically, which I don't want it to do, and I'll probably have to build something in that saves the current state and have a change node to set a flow property on the current value when it comes in. Then you can use another change node with an inject to retrieve the value again. So I guess what I'm going to have to do is somehow do like a toggle change mode thing. Yeah, the blue, the purple is and so does the red. I can see it on mine. I don't know if you guys can see it, but there are horizontal lines that come down through this. It's because of the pacing of the flashing of the LED. I can't change that frequency either. This is why I like things like VFDs and certain kinds of displays on stream, because the frame rate of the camera can sometimes really mess up what things look like. Let's just get rid of the redundancy here. Although it's a little sloppy to do it like this. Move this over. So, what was this one for? Oh, that's a get stream status late. So that's actually the same thing as this. And this just looks at true false instead of injecting started or stopped. Let's turn this into starting. So it's actually a good it's a way for me to access the other states. And this one is stopping. Is it 1p in stopping? Might be 2. Let's check. 2p's. Gotta make sure to get your PP in there. Stop the ping. Is it start ping? No, it's not. Why isn't it start ping if it's stop a ping? Stopping? They're stopping. Stream state changed contains started or stop ed. And then this one is a get stream status true or false. It's a different thing, but it allows me to get the light to be in its current state. So let's deploy, and now I can check that starting. That's supposed to be orange. It's not very orange. And then stop ping is green, although stop ping would have true here. True. Done. Deploy. Okay, so that's the status light, at least insofar as it exists currently. I will be able to get more data on this when I start and stop it again at a later date. At the end of the stream, basically, I'll be able to see whether or not bulb 1 flashes with that little red boop, boop, boop. There's the current state of the stream. We are broadcasting. This thing is red. So I'm going to put this elsewhere. That was a good session. Thank you so much, LED TV. Without you, I would not have any of this functionality. I would still be reading about it. I would be reading about all the stupid little mistakes that I was making, but I wouldn't be reading about the specific mistakes. I would be reading about other dumb stuff that I thought I was getting wrong that I was actually getting right. That's the thing. That's the thing about having a coach for some of this stuff, is that you don't necessarily apply your ability to farm answers to the right questions. You know, the little bits about parsing through JSON and stuff. You best learn from mistakes. It is a great way to learn, and it does have its consequences, doing what I was doing, which is having an expert sort of steer me towards the answers. That does have its shortfalls, and the shortfalls are in that the lessons aren't as strongly reinforced. I will forget this stuff very easily. Although today answered a bunch of questions that I had elsewhere as well, so I think it is pretty useful. I don't think I will have the memory issue on the problems that I'm having, but regardless, it is very helpful to do it this way. But doing it the other way, Googling all the wrong stuff and eventually figuring out the answer, has its advantages. It's just not great for broadcasting. Look at how dirty this equipment is. Filthy. And it's just the fascia, the veneer is what's dirty. We'll give that a good Windexing, because technology in the late 80s was of a type that was able to survive a good Windexing, unlike all these LCDs. But yeah, we can give it a good scrub and get this thing all up and functioning. We'll clean it off, and I'll put it all back together, and it may hit the shelf for a little while until I can finally find a place. I do need, like, God, if I had like a brick warehouse. Why brick? Because it looks good. If I had a good looking warehouse to put a studio into, I would definitely have an equipment wall. Have all the old stuff, all the old blinking lights and stuff. I've got that Nixie tube DRO that I would like to hook up to chat somehow, figure out something to do with that, and have it actually counting numbers and stuff, and a bunch of other visual stuff. The tourbillon, getting that up and running. Gonad would have a baby if I finally fixed that thing. The tourbillon's this 3D printed mechanism that's crazy, really cool looking. It suffered from all the flaws of being 3D printed. And if I use the SLA printer, or maybe even just revisit the whole thing on my own, reprint a lot of those stuff on my printer as it is now, it's not that much different from when I did it, 4 years ago, but we could probably get it running a little bit more easily. But it was a cool looking clock mechanism. Very cool to put something like a BRB screen on that. And then when I flip to the BRB scene, it'll turn it on and the thing will go tick tock, and then it'll be this spinning mechanism that'll have like text on it that'll tell people what the stream status is. I think that would be pretty cool. Ozbot Tail 2. What is, I'm going to Google that right now. I don't know. Ozbot Tail 2. Ozbot Tail 2 at PTZR 4K live production camera. Oh, this is one of those things. That's $1,000 US dollars. It's one of these things. Somebody was going to send me, somebody in Scandinavia was going to send me a bunch of video conferencing equipment. I thought that would have been really cool. There's a couple cameras that were sort of like that, because it was like big deal video conferencing. It would have been awesome to set that up and set up a little, like, the little AI tracking kind of thing. What is that emote? Oh, that's because I mentioned Gonad. Hey, what's up, silly? How's it going? I don't know if I want to be tracked automatically. I kind of set up my shots artistically. This is called Dutch angle. It's when I don't straighten the camera properly. But I like to kind of set my scene and have a fixed camera. I don't know what a tracking camera would look like. You ever do this with bread clips? Do you guys have bread clips over there? You bend off one of the things of the bread clip, and then it's a very powerful. We used to draw blood with these. I wanted to flick it at my desk over there, but there were monitors. I was like, oh, wait a minute. I've never gotten them to work very well. Maybe my fingers don't move the way they used to. There's always the middle finger, and then you would wind up and give it like a flick, and I would bam, and it would. You couldn't see that. That bounced off of something and went God knows where. I flicked that 10-inch propeller into one of my nice control. Oh, into one of your nice monitors. No, you gotta watch out for that stuff. I've leaked an LCD in my day. I've been burnt before. Just do a collection of all this stuff in the corner. There we go. Now, one thing we need to do, we'll do another hashtag AutoCAD sponsored ad. My copy of AutoCAD is telling me that I only have 30 days to buy another copy to re-up my subscription. So I think I need to email the creator guy and figure out what happens. Do I need to do a spreadsheet with all of my hashtag AutoCAD ads? Because we've done a lot of them in the past couple months. But I'm going to do another one. And we'll try to cover this and then put like an on-air thing above this. I think that'll be really cool. This plastic was full speed when it flew across the room. Oh, man. Waiting for DHL to come with filament. Man, look, all of this cool equipment, if Stream earned me just a little bit more money, and by a little bit, I mean thousands of more dollars than it does already, because it's in the low hundreds. It's in the barely hundreds. If this Stream made me a lot more money, I would be going with Ubiquiti home server and cameras and doorbell, and then I could look into getting 2K, 4K cameras. 40 minutes late, but Stream didn't start yet because I like hanging out with you guys and we were working on Node-RED. Why do I have to make excuses? Why am I the one that has to make excuses? This prompted me to redesign the glass holding and integrated Ultimaker clips into the bed carrier. What does that mean? A lot of those words are, huh? What? Wait a minute. With my current printer, I was able to get off of Amazon a drag chain, like a small drag chain, and through that I put that very flexible silicon wire, and I have European terminals, the screw terminals on either end, because those are shrouded, because 120 volts gets turned on and off on my bed, and with the aluminum wire, the high temperature wire, that flex, and then it caused huge sparks because it was 120 volts arcing. So I put the flexi wire in, which is one solution, and then the second solution was to guide the flexure with the drag chain. The drag chain would guide the flexure to the degree where it would break in the same spot every time, and then when I'd reconnect it, that hard spot caused a break just by the hard spot. So you have to use flexible wire in a drag chain. That was a lesson learned. My printer chucked some of the clips back when I used them using bendy magnetic bed. Yeah, those magnet beds are pretty good. I use 120 volts and I use glass because I don't need to clean it. I never need to clean it. That's that special textured surface has little bits of exposed glass so that PETG sticks to it, but then there's like a Teflon where it doesn't stick, so it doesn't lift up grains of the glass whenever it pops off. And then you just give it time to cool, and I don't need to do any kind of, all I need to do is dust it every now and then, and it just works. We need to revisit that. I had an email recently that asked me a very personal question. No, they asked about the CPAP fan on the printer, and I sent them all the stuff that we did, like all the measured stuff, all of the STL models and stuff. We need to get back to that. I need to make a blower on that printer. Unless, the second we embark on that project, Bamboo's going to send me a message like, hey, we got your email, and we decided we'd love to send you a printer. That's going to happen as soon as I start to move on. We haven't printed anything lately. It's been a time. I was talking about resurrecting the tourbillon mechanism because if I had a table and a little bit more space, I would set up the sort of the curio, all the cool stuff that we've worked on in the past. The escape key would have been one of those, but I took it apart. We had a chat activated escape key that could do patterns. Once I had my 3D printer yeet one of the glass bed binder clips with the monitor. That was my main monitor of the time, receiving a scratch right in the middle. Oh, that sucks. That's horrible. Yeah, monitors are pretty fragile to things that cut things. And I've had a few instances with a monitor. I don't have the clip of it because it was so long ago. This is 2016, 2015 actually. It was before I partnered, so it was 2015. I was streaming building my brewing system that I've not used as much as I thought I would. Building a brewing system is the fun part. Brewing is the hard part because you have to move a lot of material that's soggy and heavy. And I could have mitigated all that and made it so that brewing was super duper easy, and I should have done that. I actually had to throw out all the grains that I bought for those brews. It was old. It's very old grain. One of the grains had some kind of a fungus growing all over it, and I probably should have saved that fungus because it probably was mighty powerful in hallucinogenic properties. But anyway, it had some kind of mold across it. But the point is, I was building my brewing system, and it's a HERMS system, and so it's all electric. Everything's electric because I'm indoors here. Oh, the other problem with brewing in this room is that this gets rusty. The milling machine gets rusty because of all the moisture in the air from the boil. Now that could be mitigated with a fan, and I've tried to build a bunch of fan stuff, and that's how I sliced my hand open right before stream one time. But that brewing system, I was working on some of it, and we were putting in the main valve, the sort of food safe big valve that I got off of eBay. That's a really high quality industrial. It's the kind of thing you put on a front panel and you move the valve and it sends refrigerant somewhere or something. It was all stainless steel though. Beautiful piece of engineering. Probably worth about $300, but I got it for $20 on eBay.
So I'm setting that all up, and I turn on the recirculating pump, and my stream monitoring monitor, which was an old Dell flat screen monitor, was sitting right there, and I had the pot here, and the camera was over there. I don't know if I got a good angle on it. I don't think I did, but the output of that can go to a tube in order to drain the pot. And so the tube fitting was sitting out there in open space, and I turned on the pump, and it puked hot water directly onto the screen of the monitor. I don't think it survived. I don't think it survived. At work, I once had a self-retracting USB cord snap back to reality, oops, there goes gravity, and fling itself onto the monitor, so my successor has a hole in the monitor now. Oh my God. I had a friend punch a TV, a flat screen TV, because he was in VR. This guy and his brother, great friends of mine for forever, until that incident. No, I'm just kidding. We're still great friends. But they were driving over to my house like, this VR thing is going to suck. How hard do we lay into, oh bother, when this thing is terrible? Because we know he's going to get sensitive about it. And then they tried it, and they were like, holy shit. I was in another reality. It completely like surprised their expectations on how good it was at being, not real. Because you take off that VR headset and you're like, oh yeah, the real world kind of sucks, doesn't it? It's so bad. That's a little bit more. I don't know if I should split off all the bulb endpoints so it's a little cleaner. Maybe I should. Just put another one over here. Oh, is the album over? It is. Okay, we'll start. We're going to look at test equipment again today. We're looking at test equipment because it's fun. And I want to get this other piece clean and make sure there aren't spiders in it, because they sat in a shed for an extended amount of time. So there's no telling what kind of critters are inside of these things. The only way to find out is to take them apart. And it also lets us take a look at some circuit boards that were made an age ago. All right, so we just kind of streamlined a little bit of my handling of injecting JSON and how specifically to get contents of parts of the parsed, not parsing, but get contents of specific areas of the JSON. And this is all going to be very relevant when we get back to burn the subs. It's going to be things that will be very, very useful indeed when it comes to parsing out JSON returns from Twitch, which I don't think I have to do intrinsically. I think whatever plugin I install to Node-RED, oops, those are my lights. Wait a sec, that was the wrong button. Turn everybody back on. I could tie the production lights into OBS with this, but I kind of would rather have a button to hit, because doing stuff like that is also funny. What was I doing? I was going into setup. I was turning this off. This is all going to be relevant to stream soon. Now that I've got a cursory handle on it, I will be able to set things up that will react to JSON elements that are flowing through from an OBS not OBS WebSocket, from a Twitch API node. And so we'll actually be able to affect things, send things like a username over to the board, and then the board's task is a little bit more simple. To be fair, I probably should be offloading almost the whole board onto Node-RED, because it's likely that I could populate a database on a server that is outward facing and maybe make a web page that would enable people to look up their names on the board and find it on the board, because it's like an interactive piece of art that we all participate in. And unfortunately, I own the whole thing. It's just here. You guys can't visit it. You guys can't see it in any sort of a meaningful way unless I went to conventions. I'm not about to pay for plane tickets. I'm a big guy. I don't want to sit on a little cramped plane so that I can go get COVID at a convention. It's not in the cards yet. If there were thousands of you, maybe, but there's tens of you. So, but then I could bring the boards to a convention and be, ooh, wow, look at that. Be like a little art gallery. So the only way for me to give you guys access to that is, have all the files on GitHub, they get kind of big because it contains all of the G code, or host some kind of a page with a search on it, which somebody did. They got that all up and running, and then just like predicted, they vanished, and their code is just stagnant. That's the problem. I'm the only one that sticks up with these, these projects for an extended amount of time, and maintains and keeps them. Because I understand completely that somebody may come along and do a really good job on the project, but then what happens in the future? They obviously will move on to other stuff. So there's a big programming performance gap between where I am and running my own website. That's kind of, I don't know how I'm going to make up for that gap. But anyway, this stuff came to me from recycling, the tech recycling fairy. That's not to call my friend a fairy. He's married. Wait, that doesn't, he's married. Whatever. Anyway, my friend had these sitting in a shed for like 20 years. And these are pretty awesome. They're good if it's 1989 and you are running a lab at a university and you need students to be able to use equipment like what they would see in the field back then. It's a TM5006, which means just means that it's 6 ports of stuff that you can put into this thing. Unfortunately, these pieces of equipment are married to this because this has a proprietary connector in the back. It has little card slot connectors that will make the equipment work, which is all well and good if you're looking to make a lab setup and have a bunch of equipment in a very compact space. But for us, we have equipment on demand. We bring one single unit in and explore whatever we're working on. So it really doesn't work well for us. Plus, for about $20, you can buy an arbitrary waveform generator that blows this thing out of the water. It used to be, wow, this is calibrated and everything's all perfect and super duper nicely calibrated and works functionally perfectly. And if you buy just any old consumer product, it's not going to be calibrated. Well, it turns out that the little function generator that I bought as a kit is just as good at this thing just as good as this thing in the frequencies that we want to operate in. And this stuff is so old that it's not going to be operating at high frequencies anyway. So it's one of these things where technology has sort of moved on. Plus, because this thing was built in the 80s and it was used probably relentlessly at a lab in a university, these things are far from being considered to be anywhere near anything resembling calibrated. They're just not there. So let's get this first piece out. This one's a digital multimeter. This should be pretty interesting, and we'll see what makes it tick. It's going to be resistors and capacitors, though, I'll tell you that much. These things are through-hole technology. They have nice circuit boards, but the circuit boards are old. The circuit boards are old. So to get in, I need to have a Torx bit. I don't know why these are the only Torx bits in the whole thing, but this screwdriver that Mahala sent in is quite useful for stuff like this. Not that I need an electric screwdriver to do that, but it just makes that operation just slightly better. Just slightly better. All right, so to pull the thing out, we just have a lever. It's pretty crusty, but we'll take a look at... Okay. It may never have been unplugged from the first time it was plugged in, so I need a little bit of force on it in order to get that card connector to dislodge. Probably has some form of oxidation on it. Just give it a little shake. Ouch. Well, this is going well. Let's see here. What are my other strategies in this event? I don't have much to go on here. I mean, I could stick a screwdriver into the side and try to kind of walk it up a little bit. Or I can clamp onto that ground lug and somehow pull up on that, and that would give me enough force. But I don't want to damage it. Not that it's got a lot of resale value. I gotta get this thing out of here, though. Well, I guess just wrench on it with my hands again. This is like removing old parts from classic cars. Everything's kind of welded itself in with rust. I mean, it wasn't a temperature-controlled shed. It was out in the open. Not out in the open. It was out in the shed temperatures for many, many years. but not not out in the elements, and probably kept away from the sun too. I would assume that it was kept away from the sun at least slightly. So what I'm looking for here is a big screwdriver. I think I got a big screwdriver. I don't want to break the plastic, but I think it'll take a little bit of prying. That is a Phillips head giant screwdriver. What use is that? This one will do. This one will do, the old car boosting screwdriver. Let's try it on the edge. These edges here. Don't want to put any undue force into it. I'm trying to get like a good pry on this. There should be no other types of fasteners holding it in. It's literally just that front little slip piece and then these little pull bars. Come on, you bastard. A little bit. A little bit will do you. Ah, damn. This thing's really in there. I didn't expect this to be the problem today. All right, I'm walking it. I've got like a millimeter. You don't use an iFixit Jimmy or Jacome opener for these sorts of things? What is that? I don't know what that is. Wait, I do have tools for my car radio. Wait a second. I might have just the right thing. Hold on a second. I've been working around these tools all for years, to the point where I don't even notice that they're there. But I have little, I thought I had. Oh, maybe I don't. Perhaps I don't. But all kinds of stuff for getting stuff out of stuff. I have these two little like handle Jimmy Johns. They're not in here, I don't think. Nah. Not in there. In this one? I think they were in this one. If they're not in this one anymore, then... My brother, for his wedding, gives out a keychain ring, right? It looks like a giant cock ring. I'll be honest. It was not the best wedding gift to the attendees. Or to his best men, rather. That's why it lives in this drawer. Oh, here it is. Yeah, this little guy right here. This little hook bastard. That's what's going to get us there, I think. I knew I kept seeing this thing somewhere. I'm glad I found it so easily. I don't have a lot of iFixit tools. The only iFixit tools I really have are that screwdriver kit. And that was on suggestion of other people. Oh, that's the wrong one. We want this one. Is this going to help me at all, or was that just a totally useless endeavor? No, that's just going to break. It's too big. It kind of got around the edge, but... Yeah, that's not doing it. I don't want to hurt this stuff, but I got to get in there. Yeah, there's no good edge. I can only use it the same way I was using the screwdriver. You are just completely useless, Z Pro. Z Pro. Oh, there we go. There we go. All right. What's that look like back there? Oh, I see. It's got big card edge connectors. Big ones. That's what kept us up. All right, back to here. Bonk. Whew. That was a bastard. That thing did not want to go quietly into the night. So we got to clean up the front face, and then we'll take a look at the internals. It's just a simple matter of getting some spray on it, and then we can investigate kind of how this thing was made. It looks like it's got calibration stickers on it, and when this thing got these stickers here, these warranty void if broken, these were legal back then. Since then, in a stunning reversal of government's role in consumer electronics, they actually ruled that those stickers are not legal. If you break the seal on that sticker, your device is still eligible for a warranty. Although there are little weaselly ways to get out of that. This was last calibrated in 1999. Oh no, is this just for, wait, is it? This says Tektronix, 31st August of 98, and then 31st August of 99. So I guess these are, well, that's just the recalibration. I don't know what the date is. We have yet to find like a date on any of this stuff. We know that the system itself is from the 80s, and so that's why I based that's what I based the title on. Was this the Tektronix sort of card rack style of equipment layout is from 1988 or something like that. 84, I believe we saw on one of them. One of the manuals was from 1984. So that's what I'm basing it on. Although this equipment might be from the 90s, I'm not sure. Trying to get in between things and kind of clean it up. It cleans up pretty nicely. I mean, the crud that got on it was basically just stuff that was wafting around in a shed. So it's not really on there very hard. How's everybody doing? I want to hear about other people's projects and stuff. We're sort of at an impasse right now, project-wise, where I have circuit boards that are in production, and it's also the Chinese New Year. So I don't think I'm going to get all of my circuit boards in a very timely fashion. It's going to take a little while to get the ones for the keyboard, which are the ones that I'm really hoping on. I'm really hoping that I can forget about the keyboard project, because the more I go into it, the more I am going to be creating a bespoke RP2040 circuit instead of just putting a PicoPi module onto a circuit board. I will want to boil it down to its component parts, which is annoying because I have to lay out about 250,000 traces to make that happen. Although that is that kind of project going into fruition. You know, you build it on the perf board, but then it's like the temptation to like, why are you using a module? Just boil it down to component parts. You don't have to use the same clock they used. You could use a big clock. You have a big clock. It's huge. And you could put that down onto the board. And then it would be solderable because of the size of your clock. But like, it's so much work. It's so much work. I hate that it's so easy. I could maybe try, I could do like an auto router. We could do a Fusion 360 sponsored, or an Autodesk Fusion sponsored auto router project, and I have to sit on my hands and actually use an auto router functionally in a circuit. And maybe I would actually like learn to love the auto router. Maybe, I don't know what the state of the auto router is these days. I know that that kind of technology is very easily accessible these days. Although, what could a language model, an AI language model, do for simple circuit board decisions? See, that technology has existed since the 90s. The late 90s. The early 2000s, I was seeing ads for Altium's AI-powered auto router, because the decisions can be boiled down to simple decisions, and then you just give a pass-fail on the other end for the, whatever the decision-making is. So it's a very low-level AI can go into that sort of thing. It's not as complicated as a language model. I'll clean out these. Just got to get a little poking bit. Get it nice and moist. Oh, great. How much of that went into my drink? It doesn't really smell like Windex. I think my drink's okay. Get that Windex all over the place. I don't know why I'm so positive on Windex. I use it in so much stuff. I ran out of Q-tips too, so I can't use the Q-tips on this. I don't know. I just like having an ammonium solvent that's gentle, because they changed the formulation. It's no longer dangerous to use on monitors. They made it a little bit more plastic friendly. Polymer friendly, I should say. The MERS of my polymer. Twerk. I'm twerking it. We're twerking it, all right? T working. Twerk. All right, there we go. So, don't know about the design date, but we know the calibration date is in the late 90s. In fact, the same year that my car was new was the year that this thing got calibrated. 1999. Is this thing came before my car? Yeah, August of 99. August of 99. What the hell was I doing August of 99? I don't remember. I think I was playing with lasers at that point. So in the back of this thing, we got all kinds of cool stuff. What the hell is this? There's 2 buttons on the back. Excuse me. Positive/negative supply output selector switch. Out, front panel only, in rear panel only. Rear interface volt max to ground, 42 peak, 60 volt DC. So, out is front panel, in is rear panel. Is there front panel voltage in over here? Oh, negative, positive, and then logic. So this is 5 volts. This is plus minus up to 12 volts. That's not very useful. Oh, this is a programmable power supply. I see. So you can have it output on the back or the front. Front rear output switch on rear panel. And then this turns on and off your output. So this is a power supply that only goes up to 12 volts. The logic output only goes up to 5 volts. It's probably pretty accurate, I guess. Altium has a topological one now. What is that? The best auto routers are based on topological math and complete super quickly, much quicker than these rip and route routers like an Eagle. Yeah, from the last time I touched the auto router in Eagle, it gave you a bunch of like options that you would choose, but it takes a long time to populate them, and it sort of lays the traces, does it a different way, does it a different way. It does, yeah, just like what you describe, route, rip and route, with simple decisions behind it. Topological sounds neat. It would be good if it had, well, I mean, I'm sure it does. I'm sure the layers have been greatly complicated. You could probably give it criteria to decide on. All right, so here's what we're doing. Here's what we're doing. Oh my God. Isn't that illegal? Isn't that moral? Warranty void. If this sticker is disturbed, I find this sticker to be deserving. So this is the calibration void sticker. We are not concerned with that. The last time this thing was calibrated, we still had a World Trade Center. Oh my God. 2 years after this thing was calibrated, shit went down. So that's where my early career was based on. Oh, it's one of the ones that peels away little sections of the sticker. All right, so there's that. Use the handle of the knife to disengage these guys. And then the way these things were built, the sort of the philosophy behind the entire thing, appears to be that everything is done on these card-like circuit boards. So all the circuit boards for this thing are like modular to a degree. It was sort of very early modular design. Although I don't know if we're going to have all that much luck. Yeah, this is still a card. It's still a card. Man, no wonder DigiKey is so full of card edge connector stuff. I always wondered about that. When you go and browse for parts like raw on DigiKey, or if you open a DigiKey catalog, which many of you are not familiar with the fact that DigiKey can send you a catalog that's like this thick of Bible thin pages. It's insane. We used to browse that just raw and wriggling. We used to browse that on the toilet. But yeah, you could peruse the DigiKey catalog, and I always noticed an abundance of these sort of card edge connectors. And I'm like, why would you be using those? Like, nobody does anything with that. It turns out people were doing stuff with them. A lot of this test equipment is based on cards. So let's get the cards out of here just for sharts and gargles. I don't know why I say that. I shouldn't say that because that's an AVE. That's an AVE. I didn't come up with that one on my own. Somebody else's meme. Yeah, we still periodically will get paper catalogs from some of these places. I haven't gotten a DigiKey one, but I did get a Grizzly paper catalog, which is ridiculous. What a waste. Well, I guess it does make good bathroom reading material. So this isn't metric, but the metric does just as well to get these posts off. These posts are just so that you don't accidentally put things in upside down. Of course, then I put the posts in upside down, so joke's on me. Yeah, I don't know what project. At some point, I'll try to identify a project that we can do using the auto router. Grizzly and Uline. Yeah, Uline also. Did I get my desks from Uline? These desks might be from Uline. No, the desks are from Global Industrial. Never mind. Well, Grizzly Tools knows the value of procurement people on toilets. That's where all the real work gets done, is on the shitter. Better than the database vomit you get on the web store. Catalogs are designed with love. I don't know about love, but they at least aim you in the right direction, and they don't flood you with stuff. And they don't just, limit your what do you call it? I'm sure there's a term for it, but it's like if you're searching for a particular thing, the catalog might introduce you to a similar solution that'll get the job done that you're looking to get done, whereas a search might limit you to sort of your limited understanding of how to solve a problem. Like if I'm looking for a particular product to solve a problem and that product doesn't exist, and it's like, how are people solving this problem? Whereas going into a catalog page, you go, oh, wait a minute, there's something slightly different. Does the same job. Probably a name for that. That probably has a name. It's weird that on the edges here, they've got these little rubber pads. I don't know, functionally, I don't think that's really going to do anything. Unless during shipping, this card is wobbling around. No, there's like nothing. There's nothing. It won't move at all. So why would you soften up the edges here? Maybe somebody could get cut by... But the edge is broken. It's a broken edge. It's a nice, easy edge on that. Strange. So is this just going to pull out? I think it is. Let's see if my pull-out game is up to snuff here. Nope, got terrible pull-out game. Elon Musk levels of pull-out game. Jeez, okay. What is keeping... Oh, well, there's a big connector. There's a lot of big connectors and a lot of big capacitors in there. Holy crap. There's a lot of capacitance in this thing. I don't know if that's going anywhere. Oh, and it's held on by screws. Okay, so it does... Oh, wow. Okay, yeah. There's a big heatsink on this, so I don't really want to deal with heatsink goop. But they're dumping all the heat into the edges of this thing. What I hate about edge connectors is that you have to build a whole rig to test one board in isolation. I imagine that they would have calibration rigs to do all that with, because you're not accessing all of the analog tuning controls just through these couple of potentiometers. There's a couple of variable capacitors here too. I really kind of do want to look into this board though. Kind of want to look into this thing. It's annoying that they have so many like wire connectors inside of this, because it primarily, like that board edge should be the interface to everything. You shouldn't need to have a bunch of wire connections. Let's take a look at this other board. It's top. That we can easily get to. More void stickers, huh? Circa 99. Circa 99. You is wonderful. Mama gave you her iPhone. What could you do? It did all of the things we designed it to do. Okay, I gotta get that song out of my head. It's the problem is his vocal range is exactly where mine is, so it's a wonderful song to sing along to for me, and listening to somebody else sing along to a song in their head is actually it's considered a form of torture, and it is against the Geneva Convention, the Geneva Suggestion. So I shouldn't do that on stream. So this is probably going to be all the GPIB interface stuff, all the digital stuff that interfaces with the GPIB, which is General Purpose Input Bus. I think that's General Purpose Input Bus, the Geneva Checklist. The Geneva to-do list. Oh, God. So, like, this would be addressing of some kind through 7400 series logic, which is kind of crazy. What in the heck is this thing? Wait a minute. What the? I've never seen this part before. That's why we do this. That's why we take this stuff apart. It's because we find interesting stuff always. We always do. Always something interesting. 74LS08. We could look up all the 7400 series stuff if we really wanted to. I need to get a poster with all of the identities of all the 7400 series chips. This is a fairly interesting little product from AMP. What in the hell is this? I suppose you could break and then resolder these if you need to, or is it supposed to be some kind of a fuse? That's a lot of material for a fuse, though. Given that it goes into SP8906 or DM81L S95AN. Does it actually go into that, or does it just look like it? No, it actually goes into it. Okay, so let's look at this up. DM81. DM81L S95AN. The AN is probably not really necessary. On semiconductor. That's not an on semi, but that's some defunct or bought out manufacturer. But since it has the same part number, it'll do the same thing. On semi probably bought them. So the data sheet will point us towards 3-state octal buffer. We're buffing. If I do that around Willow, she'll start barking. These devices provide 8 2-input buffers in each package. All employed low-power Schottky TTL technology. So we're buffing and we're doing a little Schottkeying in order to make our signals cleaner. And there we have 2-state. So it's an AND, like an AND gate, but it's called a buffer. I guess you would connect one to. 4 to 5 volts input, 2 volts for the trigger. Why then does it justify this thing? What else is this going into? Those, I think, are memory. Those are probably EEPROMs, where if you peel off that sticker, oh, and they're ceramic. What luxury. If you peel off that sticker, it'll reveal a little transparent window, like these things. Where are they? Yeah, like these. These are the same thing. So you have, here's under plastic. This is some old chips that I keep on hand. But these are EEPROMs. They used to use them all the time. It was one of the only ways to get digital memory out of a device or to have something save. You know, microcontrollers now have an EEPROM on them. You can actually access the EEPROM and save settings and stuff. So that's how they did it. They had a little memory device that was baked a little bit too long, and it was able to store things in between power cycles. It was the only way to get that kind of thing on a digital device. They used to come in little ceramic packages like this with a window in the middle. And the window has plastic on it, so I can't just rake my pin tool across this and break all of these gold bonding connections. But the reason behind this is not to oogle the electronics and go, woo, look at that. It's like a little grid that we've etched onto this tiny piece of silicon. No, they don't want you to do that. They don't want you to oogle at their electronics, you pervert. What they're doing the window for is to transmit ultraviolet light onto this chip, because ultraviolet light can unwrite an EEPROM. It's just it's factor. It's just what happens. And it's what happens to a microcontroller too if it's exposed to the atmosphere and ultraviolet light gets in there. So they used to have entire pieces of equipment that were UV light baths for the EEPROMs. You'd peel them out of these things using your special EEPROM puller, because listen, even though these are a level above, I can see by the shininess of these leads that they're using slightly better metal for this, for these old school EEPROMs that are in ceramic packaging. They've got these nice leads that are kind of a little bit shiny. That's very rare. Usually we see these dull, this is dull sort of pig metal, barely passes inspection and sort of takes a tin and sort of transmits electrons. Here we have nice leads. These might bend more than twice. These, on the other hand, if you bend these leads twice, they will break off. Sometimes even once. So these being frequently removed and replaced and put back in and erased and stuff like that, you actually have some slightly nicer leads to get them in and out. So you'd use a special puller tool so that you're putting an even amount of pressure on the entire chip and not tweaking the pins as you pull it out. Totally different class of technology, man. Things that, even in my day when I was just learning about electronics, all this stuff was obsolete. So MM74C91N. That's a big chip too. So anyway, what I'm basically talking about here, what's going on? This thing speaks GPIB. It's general purpose in-out bus. And that bus was a special set of connectors that you could then hook up to your command line computer, and then further down the line, you could connect it to like a Windows 3.1 machine that has LabVIEW. And so you could automate stuff. You could bring the computer into the mix, and you could have your whole lab setup get communicated from the input bus to the device. And then in some cases, you could get readings back from the device. I'm not sure how common that was or what specific form it took. Back in the day, my day, which was just at the tail end of this stuff, we would have an I/O card. And that's where actually my example of the state of the art in 1997 comes from. That's this card all the way over here. This is a laptop card. We really should have found something to use this on, but this thing it's showing its age. It's been sort of on the bench for quite a while, and it's getting a little bent out of shape. But this is sort of this is from who made this? Might be Linear. I forget who made the card itself, but this is an electronics manufacturer making something that does all of the analog I/O. And I know the year because it is very, very prominently, where's that? Where'd it go? Somewhere around here. Made in US of A. That's right. We used to take pride in that sort of thing. Now it's all blah, blah, blah. Insert whatever rant you want to insert here, and then everybody can call me old man and I'll go back to sleep. Somewhere around here there's a giant date and that just says like 1997 on it. I think it might be in the silk screen, so I think it's on this layer. Although all that identifying stuff was, I gotta dust this thing. But yeah, this is like really nice surface mount technology here. This was way higher quality than the stuff that we're looking at right now. This bench supply. Oh, here we go. Oh, it's a National Instruments. I get the feeling that this is National Instruments making this thing, and it's copyright 1997. So 2 years before this thing got its last calibration. They were building stuff in surface mount with this sort of level of detail. This is about my level of creating electronics. I've caught up to 1997 National Instruments. Maybe I'm a little bit more advanced because I can go slightly smaller than this, and the circuit board is built just slightly better. And we got much better capacitors now. It turns out that the 0.1 UF decoupling capacitor that's likely employed in this board itself, even that 0.1 UF is pretty obsolete now. You can get a 3 microfarad capacitor for like a song and a dance, not even a dance, just like a nice, you could just complement them because it's 0.0047 of a cent each. You can get a 3.3 microfarad capacitor. We might do that for the mixer board because the mixer board is going to need all the capacitance that it can get in order to access wells of power that will be required for the headphone amplifier. So I may go capacitor shopping on some level. But yeah, this is like late 80s kind of stuff where you've got a bunch of 7400 series logic chips and a probably an 8-bit microcontroller that is coordinating memory tasks as well as just, dishing out whatever information is coming in through GPIB. And so GPIB would have a configurable address right here. I guess you got to void the warranty. You got to void the warranty in order to change your GPIB address, unless you get a pin tool into the side of the thing. That's kind of a little bit of a catch-22 there, huh? I mean, yeah, you're calibrated and you got a specific GPIB, but if you want to change it, wait, tested by who? Guile? By Gilly? By Julian? Julie tested this, apparently. I don't know what kind of work Julie was doing back then, but man. So I don't know how deep we can get into this multimeter, or this power supply. This power supply has a lot of giant capacitors, and it's got these huge connectors here. I don't know if those will go back the way they came out. I guess they might, but then the heatsink gloop that would be used on the power supply up there. I don't know how much I really want to trust this thing, because it's 1999. This is right on the precipice of the capacitor plague. Let's look that up. Let's look that up. There's a whole Wikipedia page for it. Capacitor plague. Yeah, we're waiting on circuit boards, so we're doing this kind of work. Hopefully we make some progress soon, and I can move forward. I'm designing right now the PCB for the module testing module. I want to get that all together because the technology that I'm putting into that thing's not going to change. The programming for it will. So if I can get that all together on a circuit board and get that ordered, then I'll have the tester, and we can plug things in. We get the 303s working. I can finally get that crap back to Dave and send the viewer their 303 back. Even though I'd love to keep it and have it work, I will be good on my word and get those fixed and returned. Just having the module testing module is going to be kind of a nice way to jump back into that. Capacitor plague was a problem related to higher than expected failure rate of non-solid aluminum electrolytic capacitors between 1999 and 2007. So these caps might not be, they may have been stocked in 1998 for all we know, but these are right on the line. These are right at that time of the capacitor plague. I don't see any discoloration. I don't see any bulgy-wolgies in here. Everything looks to be all right. I'm sorry I had to say it that way, but you know what? That's what show you're watching. Anything over there? It looks okay, you know? The fuses. Oh, you got to go all the way through this to get to the fuses. All right, I guess we'll go through it to get to the fuses. Is there heatsink goop on these? Doesn't look like it. So I have to release the side screws in order to get this thing out. So let me get the screwdriver. I guess I'll still use the big guy. Use the big eye fix-it one. Or not. Nope, we're not. Nope, that felt bad. That felt really bad. That felt really, really bad. That felt like I was stripping it. These are very specific types of screws, and I don't know if I have the exact Phillips head for it. You really do need to have just the right Phillips head for these, because instead, on the modern Phillips head, instead of camming out like it originally was supposed to, it rounds, it just makes it round. It makes a cone-shaped opening inside of the screw head if you have the wrong type. Did you discard the capacitor? No. Which capacitor? We talk about. Everybody's okay inside of this thing. Why would I discard it? Did I forget what I said? And then that's probably what happened. I forgot that I said something specific. And the comment was about that specific thing. And oh, there's still. Oh no, I got that one. Got that one. Got this one. And then, are there any more? No, there's only two in there. Only two of these little L bars. I gotta be careful that the L bar doesn't harm anything when it comes out. Okay, that definitely felt like I harmed something. What did I hit? Oh, I hit the little plastic stoppers back here. Well, that's... Wait a minute. How the hell am I supposed to get this out then? What the fuck? What is this crap? Let's put an L bar on it, and then let's have it not fit outside of the machine. Cool. You get your engineering degree. Yeah, I don't think there's a way that I can work it. This one fits past there, but this one doesn't, because this top of the board is colliding. So if I remove the little plastic buggy bumper. Oh, discharge. This thing hasn't been powered up since 2006. So there is no chance that there's any charge in any of these caps. And if there is, then it'll be a freak accident, force majeure at this point, because there's less than no charge inside of these things. So, I mean, I guess I can... Well, no, I can't really get a screwdriver in there because of the lip on this thing. I mean, I could release the entire panel, remove the whole panel, but that's kind of unnecessary. Should be unnecessary anyway. Oh, I can't. The transformers and stuff are actually, of the power supply, are in the way. So, man, this is a very difficult to work on setup. I guess I can undo all the screws, but I think it'll be creating more mess than is really necessary. It's a power supply. We should know pretty much what goes into this. A lot of capacitors and a lot of, I don't know, sensors. I'll just plug this thing back in. I don't know if I'm going to ever trust an ancient power supply like this. Would you? Would you guys trust that? Guess it might be okay. Yeah, I'm putting this back in. I'm putting this back in. I do want to power up some of this stuff today. We'll put current where our mouth is, basically, and plug in one of these units with a big power cord. See what happens. I don't think it'll explode. I almost trust that. I mean, this thing is on the precipice of the capacitor plague. It was calibrated 2 decades ago. And it hasn't been powered on for at least 15 to 18 years. It is, however, in decent shape. All the internal electronics are very clean. If we just give the face of it a wipe off, it looks like brand new. It was used in a university lab, so the state of it is a little bit weird. Just a little bit. I don't know. I think it'll turn on, and I think things will work pretty well. Is this thing, yeah, that's popping out. Okay. So like that, and then down here are the pegs. Recapping soon. Nah. Why would I recap a power supply like this? This is like, I can just go get a $3 computer power supply and an adapter board for another $10 and put together a power supply that would do more than what this does. Although this does do plus minus voltage, which is useful for doing the modular synthesizer stuff, because that stuff is, you know, locked in the past. Even still, though, it's like I could get a plus minus 12 volt supply that's going to function better than this thing for like just a pocket change. And I know this thing is like, oh, but for research, you want stable power for your this and that and the other thing. But man, it's like, come on. What is the purpose? And hey, these boards would be good for salvaging parts, but at the same time, I don't want to ruin something that's perfectly functional like this. You can slow start those with a current limiting light bulb in the voltage supply to the device. That's an interesting one. Why would I want to slow start it when I can fire it on and watch everything explode? It's a stream after all. And if these things explode, that would be a nice fitting end. And I wouldn't feel so bad about the state of this very nice equipment. Well, formerly very nice. I mean, it's completely obsolete. Completely obsolete. There we go. I'm not taking this apart anymore because this is a power supply. There's a lot of like interconnected things. Oh, I see. That's why they had them, because this is so far to the side that it's actually contacting the edge, and that would short it out. A little magic smoke. I hope not. I don't think there will be, though. The state of this stuff is, these were high quality electronics. They were using relatively nice parts in it. I don't think these were bottom of the barrel kind of devices. You don't use in your lab benchtop stuff, you don't use the bottom of the barrel parts. You use stuff that's a little nicer, a little bit more accurate, and it saves you headaches down the line of having to like calibrate. Which way did this go? Went that way. Having to calibrate around, bad value parts. How are you supposed to? Like this? Oh yeah, like that. Okay. So we'll close this one up. We'll close this one up and move on to the next one. There's like a custom module that I really want to look at the end of this. But the next one that I want to look at is an arbitrary. No, what is that? I think it's a multimeter. That one should be a little bit more interesting. Yeah, it's old, but it's good stuff. It looks pretty decent. I mean, in some places, that is very old. Those are some old resistors. Those are some old resistors. What is this board? Hold on a second. This is 1972? Why are we using these things? I thought we were done with these in the 90s. I don't know what specific year this device is from. Like, I don't know when it was bought. We know it was recalibrated in 1998 and 1999, which probably means that they owned them for a while and sent them to get recalibrated, because there's a sticker on the front with the calibration data on it. But I don't know when these were purchased and put into commission. I would love to know. That's why I said 80s, but I'm not sure. But then you see stuff like this with all these, these through-hole components that are like Radio Shack level. Stuff like these, particularly these brown resistors. This is what resistors used to look like. These things here used to look like these. Resistors have taken a bunch of different forms, but these big plastic mofos are generally from like the late 70s or mid 70s, late 70s, back in the before times. Yeah. Back when, what is that one? Whatever the hell color that is. It's not, they call it purple. What do they call it again? Yeah, Bakelite. This is Bakelite plastic. What was that called again? Because you can never tell on like the modern tan resistor, these guys here, these colors like this just are impossible. Why is this thing full of gay resistors? They've got rainbows all over them. Weird ring colors, they're special. But don't we have that in the regular Roy G. Biv? It was violet. There we go. That's the word I'm looking for. Violet is a color on resistors. Purple, violet. What are those? Those big diodes. I don't know what the hell that thing is. Probably some kind of a relay. Electrol. Oh, is this a Vactrol? Whoa, wait a minute. Suddenly this becomes very useful for instrument stuff or for music stuff. Electrol. Let's look up the RA 302.12.29. Oh God. RA 302. Okay, I'm going to type this with my hand on the keyboard. RA 302.12.941. Electro relay. Okay, so it's not a Vactrol. I was hoping it was a Vactrol. 115. Probably nobody's buying it for that price. Yeah, it's some kind of a reed relay. What did I just click? No. Get me out of here. Get me out of here. I didn't do anything. Oops. Control-Shift-T. And back. There we go. Tektronix. 070215503.pdf. Of course, the famous. I remember this PDF. Spectrum Analyzer Options Instruction Manual. What? Why did the relay come up on this search? Oh, dear Lord. Wow, this is back when they'd give you a full schematic of this stuff. Yeah, see, there's the part number right there. Why is my window frozen? Oh, because we have like no results. The data sheet is a multi-data sheet. No, don't download it. Ugh, bastards. Yeah, I actually kind of remember this page of the catalog. I remember the relay page of the catalog because they've got all the different circuits that are internal to the relays. Relays used to power a lot more back in the day. You had ladder logic and stuff like that. I always loved looking through all the relays because you're like, I'm going to flip a switch, but it's going to be cool. It'll look cool inside. But yeah, that's okay. So it's only a relay. I was hoping that it would be a Vactrol, but Vactrol is something that musicians made up. It's just a light and a photoresistor connected together. And if you put current through that and you put music into one end, you will get sort of regulated voltages out the other side. It's a way to make a compressor. I can hear the phantom clicking in the distance. Those are the sounds of the machine god waking up. I always love that. You turn on a piece of equipment, it goes. Not a lot of stuff does that anymore. So of the electronics that we can access, they're all sort of the same era. Those are Well, actually, usually stuff like this in like a white container is some kind of a photo opto isolator. There we go. There's the word. Yeah, you could just put an LDR and an LED in a tube and use shrink wrap, or a photodiode and an LED, but that has different properties to it. The Vactrol that they sell for like $14 each, and the thing that Julian had me replace once, it is literally just like an incandescent bulb and a photoresistor. I think it's specific to the properties of those two, because when you move over to LED and a photodiode, it lasts a lot longer. There's no filament, but the electrical properties are a little bit different. A little bit different. Used to give an envelope. Yeah, there it is, envelope. I thought it was like a compressor of sorts, but I guess that's just how it works. That Electro Projects page has a lot of stuff like that. The German website for the guy who made my amplifier circuit for my microphone. And I kind of modified the circuit that they did to have a slightly different power supply, but it is still fundamentally the Project 93, I think it was called. That site is amazing, and I need to be doing more projects from that site, from those schematics, because there's some good stuff there. Although mutable instruments circuits have been indispensable for doing modular stuff. Because it's like, here is the culmination of somebody's career in building synthesizer modules. Did I put them on the wrong side again? No, they're on the bottom. They're on the bottom. There's just a lot of things that need to connect simultaneously in this thing. They're on the bottom. So this goes down like this. And assuming that it's in alignment. There we go. All right, on to the next one. So that's going to be this big guy right here, this programmable digital multimeter. That should have some interesting stuff, right, guys? Guys, where'd everybody go? I've yet to play with a Vactrol. I want to kind of make one and mess around with it. All right, let's get this stuff out. Next. God, I slept weird, so now when I bend over, it feels like water is in my ears. I don't know if I'm the only person to get that. that might be a serious health condition. Oh, that one was nice and easy, because it has very few connections. It has two little tiny connections on the back of the multimeter. You would think that it would need a little bit more to function, but apparently 2 little card edge connectors is all that it needs. I don't know how much busing and digital technology was really available at the time. We'll find out if there's any sort of a semblance of a date on this thing. We'll mark it down. It means you got to clean your ears. I've cleaned my ears. My ears are spotless. I could probably use peroxide on them, but my ears have been leaky. Not leaky, but just like they feel like there's water in them because my showers are too long. Light bulb is a PTC thermistor, so it can compress audio and has a few more interesting uses. PTC, huh? The filament light bulb. Oh God, that was a nasty little piece of dust there. So mostly what I'm seeing is that these have a very superficial layer of dust on the front of the surface. They look like they're in hell. You know, they're just deteriorating. But get rid of that superficial layer, and everything underneath it is pristine. Is it? I thought PTC was a resettable fuse. I'm, of course, wrong about everything all the time, so. All right, so cleaning that up makes it shine. Beautiful. Looks like new, except that it's, got that yellowing of old things. I don't think these started out white. I think they were sort of a light gray. So the yellowing is a little bit less noticeable. Light bulbs are out of production. You can still buy them. People still make them. I had to go through that with a makeup mirror recently. They don't trust the frequencies of light that are coming out of LEDs. So I had to source a bulb, and it turns out they just had them at the supermarket. There's nothing complicated about getting an incandescent bulb. Just had to go to the place where old people shop for bulbs. Like Ace, well, the Ace Hardware around me closed down. So the only option is to go to the grocery store where you can buy $13 eggs. All right, LED screen. Bunch of different things that you can do here. Programmable digital multimeter. Now, enable ohms chomp. Would this have been useful for tuning the instruments? Probably not. We don't have a calibration sticker on the front, unlike the power supply. I mean, you can also just buy incandescent bulbs on Amazon. Like, you don't need to necessarily go to a grocery store, but still. Anyway, why is this so warm? This light is way too warm. Hold on. Hold that up a little bit. That is just far. Now it's just, oh God, it's a piss light. We've got a piss light on over here. And this is super blue. So we're going a little bit, we want 45K. That's about right. Tiny little bit of warmth. That's it. If you have a terrarium, you may need one. Oh yeah. Yeah. For heat. Auto range, DC volt, AC volt. You can change the range over here, which I don't know if I really like in a multimeter. I think the one that Wexos sent me is far more powerful than this. And the one Wexos sent me was a superfluous old multimeter, but it was a desktop multimeter, and it has the appropriate resolution. What does this one go to? We don't know. We don't know until we can power it on. Or look it up. You just look up the DM5120. Cool. Pretty cool. I mean, it keeps your students from walking away with your multimeters. I mean, it didn't keep me from walking away. I didn't steal this from the university labs. They were moving their labs and they put this stuff in the garbage for people to pick up. And my friend picked it up over 10 years ago. This is like 18 years ago he did this. So we're going to tear it apart a little bit. These are easy to tear apart. They're not much of a disassembly. But anyway, my point is having these things and having the screw locks on them, it keeps your university students from walking away with all the digital multimeters. It turns out very portable digital multimeters nowadays blow this thing completely out of the water. I mean, it's ridiculous. So university garbage bins are the best. Yeah, they were just getting rid of a lot of this equipment. And my friend, I helped a little bit, but he was the one that was like, dude, they're cleaning out all the labs. They're redoing all the labs. And this was like a couple years before we graduated. By the time we graduated, I think they then updated everything. So we had all this shitty equipment. But he, even from one of the optical labs, got some kind of a prism thing in a box that looked like a piece of crap, and it sold for $600. Some hobbyist optical experimenter got that thing for probably pennies on the dollar, but it sold for hundreds of dollars. And we were like, oh my God, that was a goddamn fortune for us 18-year-olds. Public surplus website has all the university garbage bins on auctions. That's pretty good. Yeah, we used to go to stealitback.com, which is where all of the police auction stuff was. So you could get like road equipment, or you could get, for us, it was fish tank lights, because I don't know who needs like, such a powerful little sunlight. Why would you want that much light? It's not, all you could use that for is like growing plants, growing certain illegal plants. That's what they used them for. Yeah, it was all of the pot seized grow lights. Let's just peel that off. But yeah, we would buy those for pennies on the dollar and then put them into our the old kind, not the LED kind that we have now. I don't know anything about that, but grow lights were really good for fish tanks. So I had a big fish tank. I loved it. It was really fun. But that hobby was also one of these hobbies that requires way too much money. So I dropped it. And you didn't meet girls through fish tank stuff. So me neither. Yeah, we don't know nothing about nothing. We don't know nothing about nothing, officer. I brought that from home. Where is the big screwdriver? Oh, here it is. We're just going to peel up the side panels and take a look inside first. Ones of the power supply that risk tripping house breakers. I forget what power supply I had to buy because those lights have to like warm up and then they turn on, and you can never, never, never touch it with the oil of your hands. Because the oil in your hands will provide a heat spot that will shatter the light. All right, so this one is not using racks of cards. What the heck? What you're going to do is you're going to put a big box in it, and that's going to make it feel like it's expensive. Actually, I think this is a shielding box. Wired. This is very strange. All right, so let's get further into it. These boxes contain boxes. Apparently the frequencies that get in through this hole pattern are too much for the digital multimeter. You can fascinate me with a fish tank. You've been dating the wrong girl. That's true. Meeting the right girls is probably the big problem. It's the internet has given me much wider breadth. What was the one from that one book? You can fascinate a girl with a piece of cheese. I always loved that one. I would be fascinated too if you just handed me a piece of cheese. Like, whoa, what are we doing here? What is this cheese? All right, so let's see. This one was for the locks. Oh, we're going to need that one more time. I'll put that to the side over here. And then this one is the smaller one. The smaller one is good for these. The larger one is good for the... Well, actually, is this one okay for these? Yeah, okay. So we'll do these. Give somebody a box with a box in it. It'll fascinate them. They'll be yours in no time. This one requires us to take it apart on sort of a more lower level than the other ones. The other ones were nice and easy because you could just take stuff off and remove all the cards, and that was enough to kind of look at everything. If a girl were to randomly hand me a piece of cheese, I would be concerned. There was that other post that was from a little while back where the girl was dating a farmer and he gave her a wheel of cheese, and it's like, girl, like he gave you a whole wheel of cheese. That's awesome. You can't look down on that. It's an amazing gift. If I got a piece of cheese, a wheel of cheese, I'd be over the moon. Actually, I wouldn't know what to do with that much cheese, to be honest. I go through a lot of cheese. You guys know I'm a fairly rotund individual. I am definitely downplaying that a lot by saying it that way. I don't think I go through wheel of cheese levels of cheese. Oh, that's slipping. I'm gonna have to use pliers on that. This isn't English size. This is metric. Let's try to find the English sized one. That means a little bit more digging, and I don't know if it's in this or a plastic bag over in the other drawer, because I very rarely do stuff with English sized bolts, and we need a deep socket for this. So that one's too small, I'm guessing. Too small. As Donald Glover would say, too small. I could use an open-ended wrench. I think I have the right size open-ended wrench. Yeah, none of the English ones made it into here. I have this old Craftsman kit of sockets that was really good, but I rehoused them all. They're all in a different organization thing. So what am I looking for? Oh, I'm looking for the wrenches that are right here. I have all these guys that I bought. I bought a small wrench kit. It's not high quality, but depends on how good the cheese is. That's true. I mean, anything that's in a wheel, I don't know. Does low quality cheese start off in a giant wheel? I think only the really good aged stuff makes it into the wheel form. Is this point about being cheesy? Oh, jeez. Were I a little bit more clever, I could have worked it into that. Single slice of cheese and a wheel of cheese. Yeah, there's a little bit of a difference. You know, you have a fairly salient point. That doesn't even feel right. What is, too big? Too big. Still? But it doesn't really, this is 13/64. The English method of fractions is far superior to your metric 5.5 millimeters. Instead, we get 13/64 as our wrench size. None of this millimeter garbage. Clearly superior. Let's try 5 millimeter. Yeah, gripping these with a wrench is probably the inevitable solution. I'm just trying to like a vice grip, like a plier, some kind of plier. I'm just trying to be kind and actually use the right stuff on it. I don't know if they were using metric or English though. This was the 90s. I will eventually. Yeah, that's inevitable. That is inevitable. It's also inedible. Don't eat needle nose pliers. Needle nose pliers are inedible, but they're also inevitable. What about 7/32s? 7 out of 32. It's very easy to remember, easy to work with number. Why is that larger? It's way too big. What about 5 of those 32s? Instead of 7, we have 5. Which is, that's a, you know, the difference between the two numbers is clearly a very logical product idea. Edible needle nose pliers. You sell them near the edible panties, I guess. It's like a tool guy thing. That's my fetish. No, this is not working out. I do not know what the hell size these things are supposed to be. These pegs that they put on the back of this thing are supposed to be of a particular size, but they sure as hell did not. What they make a special size just for the. I mean, we were using a. Is this the one? Yeah, that grips it better than the others. This is a 5 millimeter. Some of these will probably be able to get to move. No, they're not really conforming. This one, yeah, this one I got. This one slipped, but maybe if I push down on it. Oh yeah, 5 millimeter seems to be the best I've got. Tamper resistant size. Yeah, they made up their own size so that people couldn't tamper with the equipment. Boy, if you're on this level where you've removed the thing from the rack already, and you've gotten to the back where all these fasteners are, like, you win. Like, this is it. You've won. You've won. There's no point in having any more technology attempting to lock you out of the device. At this point, I'm in control. You might as well just let me in. Yeah, I've already taken it home and discovered that I can't power it up. And I know my professor is like, where the hell did that thing go? Why is it missing from the rack? I've got the cops beating down my door already. You keep what you kill. The metrics, a mystical time when standards were not yet standards. Metric is just so much easier. I really wish my country didn't boggle their opportunity to switch. Maybe when the boomers are dead, we can go back to attempting to be metric. But then it'll be seen as un-American by certain people. And it'll be this big controversial thing. Instead of, you know, progressing forward, we always have to seem to regress in this fucking country. That's what's going on right now. But I'm glad you guys are here with me and we're avoiding all the bullshit. So I will not talk about anything else related to that. I really don't want to damage this because it's got to slip into a piece of plastic at the back of the device. So my options, as it's not really moving with the pliers, are to either get a pair of vice grips and really crunch down on the thing. That could leave a big mark on it. If I do use something like, regular pliers, these are as close as I get to regular pliers in that drawer. Regular pliers, this might not grip properly, and the movement across it can score big marks in it. That's why I like using this pair of pliers, because it's got these horizontal sort of, not knurled, but they're like horizontally cut grippies. This has to come out, yes, in order for us to get into the device. This isn't made like the other ones. Well, okay, it isn't made like the other ones, so maybe we could get away with it a little bit better. It's not necessarily vertical cards like all the other ones. What head is on it? There's a hex at the base. It's the worst of this type. If this were car stuff, you would have additional, yeah, see, I've already started to score lines in it. All right, let's get the hex grips, the vice grips. Jalopy, what are these? Nope, it's the right size. It's 5 millimeters. We tested with the open-ended wrenches. It is not an English size. All right, vice grips. I don't know where my vice grips. My vice grips are with my car tools, which I do not have sitting in front of me. My car tools are in the garage. There might be a set of vice grips in this drawer over here. Hold on, I gotta go spelunking for tools. Oh my God, why is there a giant knife in here? Here's a pair. Here's a pair of vice grips. Put her there. I used to have miniature vice grips. What happened to those? They probably got stolen by a friend of mine. That's what always happens. My friends see these weird tools that I buy, and they end up absorbing them. Magically absorbing them. I like my weird tools. All right, so we take this all the way down until it's just a little bit smaller than the fastener, and then I can get a real tight grip on it for sure. Okay, no, we gotta make it smaller than that. They're a little wobbly at this size. Nipex miniature parallel jaw pliers. Yeah, I need to get the miniature vice grips. They come in these hilariously tiny sizes. So I'm putting a lot of pressure on this, but this fastener is probably a little bit weak, so I do want to give it the benefit of the doubt. I don't want to totally wrench down on it because that'll cause it to deform in the jaws. All right, so I think that got it started. Yep, there we go. Okay. And it looks like I didn't put a huge mark on it, so it'll probably still fit. Although I don't think I can use the socket to get it back in. Maybe I will. Maybe there's enough grip on the front of this, but man, these are not good fasteners. Look at this thing. Oh yeah, so one of the tool guides channels that I follow, they actually did a review today of these things. So I actually bought a tool before seeing their review of it, which is rare because they seem to review a lot of tools that I'm looking for at the time. But yeah, this is this rare instance where the tool guy reviewed this before or after I bought it, like well after I bought it. This thing's pretty good. It's okay. Smaller wires it has a little bit of trouble with. If I was doing a lot of 18 gauge wires, this thing would be great because it's a different motion than the normal wire strippers. Although the flatulent gonad method of taking a flat pair of pliers, as seen right here, and then your wire strippers, just your simple, good quality wire strippers, and doing this. All you need to do, grip the wire, grip the stripper, and just twist like that. And that'll separate it out, and it saves you from having to wrench on your hand and, you know, getting all kinds of weird repetitive stress injuries. But those strippers would also do that job pretty well too. If I had to do like 118 gauge wires, this thing would be pretty good at allowing you to not have your wrists in weird positions, and you're literally just doing this over and over again. So Grip the stripper, yes. Well, not in the champagne room. Not in the champagne room. Not again, anyway. Okay, that's that panel. Now I've got 2 connectors that are going to come with us. You can tell they are going to come with us because they've got these little screws in them. Oh, that's nice. That's nice of them to do. That is very professional. Come on. I thought you were a professional test equipment company. Look at, okay, so what is Bother annoyed with? They have bolts on the back of these screws on these panels. You really shouldn't, at your level, you can tap this aluminum and it's just fine at taking a machine screw. Or you could even not tap the aluminum and rely on the interface between the aluminum and whatever, or maybe find or use a threaded insert in this, something so that I can remove this from this side and not have a bolt fall into my digital multimeter. Hey, what's up, Code Rush? How you doing? 30 people from Code Rush. That's gonna put us over in numbers. You guys are gonna have to get chairs from whatever the next stream is. The stream over, like the not to the left, to the right. You're gonna have to get some chairs from there. We don't have enough chairs. But yeah, Code Rush, welcome. We're looking at a digital multimeter that was part of this Tektronix sort of multi-device rack system. Basically, you had a certain number of slots and you can put your test equipment in there. Really good for like a factory setup or like a test setup or a university setup where you don't want people walking away with your equipment and you've got sort of a fixed test setup that you want to have happen. So this would be really good in like a factory if you're building a device and you need to have multimeter functions and stuff like that on like a test routine. Because all of your devices plug into this one thing. This one thing has a GPIB, which is a general purpose input bus, so that you can send it a program and it'll set itself up in a particular way. It'll have certain ranges of output voltages and input voltages and measurements and stuff like that. So really useful for that. Absolutely abysmally stupid for me. I don't have a 19-inch rack that can take my rack. You know, I'm fairly boobily myself. I'm well endowed with some rackage around here, but my rack could not handle the weight of these devices, of these little boobies down here. Could not handle it. That's not to say that I couldn't build a rack that does, but we don't have an overabundance of space in my work area. Those used to be clean surfaces, and nature abhors an empty surface. Hell, I've even got some more test equipment all the way back there. At some point, I need to make a wall full of test equipment, which is where these things, I guess, would come into fruition. But they're so long. Like the devices themselves take up about that much space, and then there's this whole back piece with like a giant transformer and stuff. Time to start on the ceiling. If test equipment were like books and it absorbed sound, it would be great for the shop. Yeah, if there's a surface, it must be filled. So this is Drexel University stuff, and Drexel went through some changes in their engineering department, and so we moved from the disintegrating giant main building over to a pie piece shaped sort of office building like structure. All of the labs were funny shaped because of that pie piece, but a lot of the equipment moved over and a lot of it was gotten rid of. And so my friend and I were positioned just right to receive a lot of this stuff. I didn't actually grab this stuff. My friend actually ended up with a lot of the engineering department stuff. And I've got a couple things from him that are sort of in storage and some that I use to this day. But this stuff came just recently when he was cleaning out his shed. And he went, oh, God, I still have those things. You want to check them out? And I was like, hell yeah, do I want to check them out? Like, let's get that going. Turns out these are pretty useless. Not only because these things use this card rack connector to get power in and out, and they have their GPIB connectors like as 2 separate entities that interface with sort of a bus on the thing. It's like, I can't run this. I don't have I need something to plug into the back of this thing in order to run this like a piece of equipment. These would be very useful to me if they were individual pieces of equipment, but they're not. They have to be run inside of the giant rack thing. So I'm at a bit of an impasse with these things. I guess I'll keep them around, and maybe one day I'll be able to plug them in and just have them like running blinking lights. But I need to at least give these the benefit of the doubt, take a look at them, possibly power up one of the units. Maybe we'll power up this one when we're done with it, because we only have one other piece of equipment to check out in here. So there's no calibration sticker on this one. The calibration sticker we found on the digital no, this is the digital multimeter. We found a calibration sticker on the variable power supply, and that had a date of 1998 and 1999. So the last calibration for the units in this rack were from 1999. That says nothing about what year these were actually produced. We're looking for any kind of like a year marking, something that'll tell us what year this thing was produced. I need to know. So they put all of the digital multimeter electronics in a can. The purpose of that being to isolate noise. Noise. I can get rid of this piece and move it to the side with the 10,000 bolts that are right here. Now the thing about Phillips, and especially crunchy ones, the stuff like this where the screw's been in there for 30 years and it's an old style Phillips screw, they're not using great material at this point in time. We are screwing a steel, possibly screw, onto an aluminum. I don't think these are stainless. I don't think they're using that quality of screw. So it's possible that a little bit of a half cell reaction has happened between the screws and the aluminum, and these could very well be welded in. And we haven't really experienced that. I think these were kept in a pretty clean environment. They weren't too moist. It's Pennsylvania, so it does get pretty moist around here. But I think they were, in a university, and then after that they were in a shed. But I don't really know if it got too moist. But these screws can fight back if they weld in. And because the Phillips head has been bastardized through history, it's one of these lost technologies where it used to be that you screw in the Phillips head, and when you get to there being too much torque, it'll cam out and pop out, and you go, oh, I'm done. That's cool. Forensic alphanumeric carbon dating. I don't know if we want to be doing that. But you mean like if I look at the serial number, maybe I can figure out what year it is? I don't know. So with these screws, with these Phillips head screws of this era, it's very important that you get the right Phillips head to complement the screw. There are all kinds. There's more than you would ever think. It's not just a plus sign. There's way more engineering that goes into a Phillips head. There are even aeronautical standards where it holds onto the screw, because the last thing you want to do is listen to a screw bonk its way through the compressor element of a turbine, which I've seen and heard before because the internet exists, and somebody went to an aeronautical graveyard and dropped a thing down there. Torque tip. Well, I don't know what the specifics are. There's all kinds of different weird ones. But what I've done is I've found the largest Phillips head that will fit the screw. Anything larger doesn't get into the actual Phillips head itself. So the largest amount of area of contact that I can muster is being mustered. That's really important to do. Otherwise, you risk stripping screws out. So these are cooperating. Some of the ones earlier almost didn't. And you don't get a lot of chances with these things. You start unscrewing it, and if it, instead of camming out, it just destroys the edge that you're supposed to be using to unscrew. I've had this happen a lot, especially in automotive stuff. Around this state, Pennsylvania, because we see so many freeze and thaw cycles, we see a lot of salt. And the salt here in the Northeast is insidious shit. It's really bad for cars. It gets everywhere, and then it facilitates a nice little half-cell reaction. I worked in aviation for 6 years. We had a not quite Phillips head called a torque tip. So that is what I'm talking about. Yeah, it's got these little nublins on the side there. There's like a little bit of a texture that grabs into the Phillips head. Oh, this one is stripped. So what I'm going to do here on the stripped screw, instead of going through all of the many stages of grief when it comes to figuring out that a screw is in really bad shape, I'm going to push down on it as I unscrew. Here, take a look. Oh my God, it's gone. Where is it? There it is. This one has been pre-stripped. There are no hard edges. You see, like over here, you can kind of see the area where this thing is supposed to contact. This one is in shit shape. It is not good. Some of the ones that I already removed are in better shape, where you've got at least like well, no, not really. Somebody took this apart before I did. See, we're looking for those little those little edge areas, but look at how little there is. What a crap design. It's so bad. It's like almost a security screw. So I'm pushing down as I unscrew. There we go. Whoo! Gotta slow down, get a feel for it, see if it's slipping. Because if you do strip it, sometimes you'll keep turning, and that'll further drill out your screw head. Now, of course, obviously, if things went totally awry, I could take a drill directly to it, and then the head would pop off, and it would be fine. But that is made to do what we just did. That is why they used the length of stuff that they did. Not much for getting in here, though. So what do we have here? Looks like we have the power supply. And that has... Okay, the GPIB stuff is elsewhere. Is there a date code anywhere on this? I don't see one. Down here, maybe. Take a look. We'll take a look. I gotta check to see if there's any activity. Nope, just Code Rush, rating 30 years ago. Bonk. Yeah, they're not quite tamper resistant, but they do seem like they are. That almost looks like 82, but I don't think I'm going to take that. PPI2Co. What does that even mean? Probably internal stuff. But over here by the fuses, that's just, okay, slow blow, 250 volt, 375 amp. I mean, we don't want it to go too quickly. That's a nice slow blow there. Don't be gross, Father. Capacitors look like they're in good shape. I mean, this is the year of the capacitor plague, according to the date that these things were calibrated. It was 99, which is the beginning of the capacitor plague. But I see no signs of the capacitors being in any kind of stress in these devices. So I think we might be in decent shape. What the hell is that thing? What could that be? What could it be? This is all power supply stuff, I think. The real meat of this device is going to be inside of this can, though. We need to get the can opener out and open this thing up. So how am I going to get into this? This is just for shielding, apparently. Everything else is just metal can. And there's 2 PCBs? What the heck? All right, well, let's get into the surgery of this thing then. I really don't want to separate this from its connections over here. But they didn't give it a connector on the other end. It's just soldered, wires soldered to the board. At least they did it right. They did it the way that I recommend, which is they actually have a crimp on those wires so that when you're handling the device in the way that I am right now, you are actually flexing the flexible part of the wire and not the metal part of the wire. If you don't use some kind of a like strain relief on it, then it can be really, really bad. Like your wire can just pop off when you're assembling. So you want to use an actual crimper, crimp something on the end of the wire that braces the jacket of the wire, and then you solder that crimp onto your board. Or the cheaper method of doing it, if you have room for it, is you have another set of holes next to your soldered connection. So you solder connection, and then you loop your wire down into the hole, down and up sometimes, or just down through the hole, and then that gives it more of a chance to flex on the jacket of the wire and not the wire itself. The wire. Okay, so I kind of want to make a note of where all this stuff is before I go unplugging it. So notepad, and I'll just come down here, bottom of this stuff that we're not going to need, and do the wire colors. So red, orange, where's that one? Black, gray, grayu. What are these down here? That one's white. What is the one next to it? Wait a minute, where are they? Oh, I see. So it's that loop will keep in, but then white is the last one down there. So it's loop, white, loop, loop, white, loop. There we go. Okay. So I got that written down. And the question is, are these going to be the types of crimps that require me to... Nope, never mind. Sometimes you have to come in with a pin tool and push the other side so that it dislodges. But these just require a little bit of elbow grease, and then they come off. There we go. Now I can put this aside. So this would be the front panel, and then I guess this is possibly the power supply, although we've got a bunch of wires coming in here going into a transformer. So I have to assume that power is being dealt with right in this area. This might be GPIB, because there's EPROMs near it. Is there a date on that? No, just version number. Huh. Cool. Okay, well, let's put this aside. There is no aside. Every single feasible flat surface has been taken up with SUF. Damn you, laws of physics. the lab physics fundamentals. Nature abhors a flat surface with nothing sitting on it. I really need to go through and clean off all of the surfaces in here, and I need to go through the big pile of project stuff in the back corner of the lab, because there's some old projects in there that we haven't done anything with that I can put into a little bit more storage. Always too much, but never enough. Yeah. Transformers. It's an electrical transformer. It's not that kind. Everybody wants to sing the Transformers song. Okay, this thing sort of became wobbly all of a sudden. These are like modular. These are fundamentally very modular. So even these panels are modular panels that go together to make this thing. Kind of a cool system, though. If I was ever trying to make like stuff, like lab stuff, it would be kind of cool to have all these weird panel-y things. What the hell am I looking at? This is just like an isolated FR4. What the? Huh? Okay, so these posts aren't connected to anything. It's the screws that I need to get at. This is crazy. This is a weird thing. This would be where all the multimeter stuff goes in. It gets measured. And then I guess the rest of this thing is all display. Like, I mean, part of this has to be part of the readings because the front panel is connected to the base, not directly to this board. So this board would be doing the measurement, and then through some of these connectors, which are right next to where all the power's going in and stuff, they would be relaying things digitally, I guess. I would assume. Maybe this is additional shielding? Jeez. Let's find out. The design of these things is very straightforward. It's actually a pretty good piece of test equipment. You want your test equipment to be straightforward and functional. It is just a big piece of FR4 with a big trace on it, a big not trace, just like a big ground plane, big isolated ground plane. Somehow this one is super duper isolated. I don't know what the justification behind that is. This one is super isolated. These have just boxes around them. Are these even metal? I guess they are. God, my hands are filthy from these boards. Probably a lot of really bad stuff on them. But then there's nothing on this side. Like Legos, almost looks like everything is just fit together from a big bin of parts. Somewhat, yeah. I mean, they've got like a rack system. So there's like a standard measurement for each device. And then I guess it looks, everything else is kind of a little bit modular. Like you'd have a front panel that you would take all of your cuts out of in order to make the front, but then you have different screens that you could put in. But then for the case itself, it's like they're made out of these different types of rails. There's ones with channels on them that put pressure on things. There's some that have little like external bumps that'll fit into the whole rack system. And the rack system has GPIB and power connectors at regular increments. So you would say, oh, I'm within this size and I need this many of this panel and this, I can use this side panel. It's kind of crazy. And I guess Tech made a whole bunch of equipment with that. I don't know what other stuff there is. There's a list of it online. Is this free? This is free. What a free. Any other fasteners in here? Nope. We can just take this out. And I guess it's not. Wow. So instead of like a little RF can that you would solder in, like hold on, I got an example up here. Like, you know, you take a little bit of metal, you solder it down, and that would make your little RF blocking can. Instead, they have this giant aluminum box that they created, and they put FR4 on top of it, and then they used a huge piece, an extra piece of FR4 with a giant ground plane, and put that below. Even just like a 4-layer circuit board would be better than this. That's crazy. So what is so important on this board? Maybe we'll get the vice grips away from the sensitive electronics. Maybe we'll just do that. So we do have some pretty dense engineering going on here, although it is through-hole, which I abhor. I do not like through-hole. I'm a big fan of surface mount because it's so much more organized and neat. Look at those right angles. All of your electrons are gonna be swimming around. Your electrons are like, oh, everything's great. We're gonna totally go to the next destination. They get to this corner, they go, and they run into the corner, and then they spill all over. You get out. No, it doesn't matter. It doesn't matter. The right angles are not that big of a deal at low frequency stuff. Like things your digital multimeter is gonna do, not really all that crucial. What in the hell is going on there? Wait a second. I just got done defending you, and then you do something like this? What? So they left whatever trace that is, they left it exposed, and then they allowed the wave soldering to go over it and populate solder onto the trace. And what that does is that allows your fairly small trace to carry huge amounts of current because it's got all that extra metal on it. So it becomes a vertically thicker trace instead of a horizontally thicker trace. And in this case, it is a completely wasted effort, and I really wonder why they even did that, because they could just have had a very thick trace going directly between all of these pins. They got plenty of space, although I think maybe their manufacturing capabilities mean that, because like if this is the minimum distance that they can separate things, then yeah, that's going to be a little bit of trouble. But I mean, if you had just continued with the 45 degree and then gone straight out here, and you have to somehow weasel your way around this stuff, I could still justify a larger trace on this instead of a soldered one. This would be like a last resort. It's what you do on like power supply stuff. It's interesting though, this is a matte solder mask. I'm not used to that. Usually for these other boards, we'd have a glossy solder mask. This is looking a little bit more modern than the frequency generator PCB, which was like the blue thing that was like rotting away. This looks a little bit more modern than that, but and again, we don't have proper markings on these. There's no silkscreen, at least on this layer, so we don't have like a date code anywhere. It's polite to put a date on all of your on your electronics, just to tell somebody what year the thing came from. Here, the people who come after you. This is not 2022 for sure. I did not just steal this from somebody who's still looking for it. Not 2022. What was that one? One designer going around the other designer? Could be. I mean, the style, I don't know. Like, look, what is why are you not going diagonally? You go diagonal over here. Why is this one not vertical? Weird decisions in some of these things. I'm trying to get back to that code over there. 1988. So now we can put our finger on it. These are made in 1988. So I was right. This is from the 80s. I mean, it could be 1980, but that really does look like an 88 just covered in solder. I could take solder braid to it and try it. Let's do that. Let's take solder braid to it and see. What tip do I? The perfect tip. The perfect tip. I'm not a historical preservationist, all right? It is 88. 1988. 1980 nothing. Okay, I fucked it. Oh God, oh God. All right, well, maybe we let sleeping dogs lie. I'm not going to touch that anymore. That was ugly. That was very ugly. We know in our heart of hearts what year it's from. a year when they can't stand that much heat is where they come from. Yeah, maybe we can blame it all on cocaine. They all took a Miami vacation and designed some circuit boards when they got home. Jealous of them for being able to design circuit boards for a living and make a good amount of money on it. But then they do stuff like this that just violates your trust. I no longer trust them with anything. Whatever the hell is going on right here should be a cry for help, let alone a method of building something. I now do not regret getting rid of that extra 8 by accident by overheating it. No, sir. Yeah, whatever interface they have, like for the FR4 to the main board, is abysmal. It's really bad. To not be able to take the amount of heat that my soldering iron brings to the table with a piece of braid on top of it, and just that looks like my Factorio map. I said it before. I'll say it again. Oh yeah, these things are done to not trap solvent apparently. But yeah, the Factorio Satisfactory, the parts of the brain that those games itch are the same parts of the brain for laying out a circuit, only a little bit less so because it is a game and they're fun and you're having fun. If you play those games and you know electrical engineering a little bit, have what it takes to design a circuit board for yourself. Don't short sell, especially if you're doing audio and low frequency. If you need an RF board, there's a little bit more to it, but. So yeah, that ferrule is there to clean up the signals coming in, I guess. And this is a multimeter, not an oscilloscope, so they don't need high frequency anything. The traces are very small though. A lot of supporting equipment, but then when we get over here, we've got some kind of a modification. So 74HC0. Yeah, 74HC0. And then some kind of a 411GR-001. Huh. I wonder what that thing is. But we've got modifications. All the space that they had on this board to run all of these different connections, and they biffed it. They messed up and had to do bodge wires. So listen, you're playing Factorio and you go, oh man, I got to run this belt down and around instead of just running it straight over. I can't believe I've got to rip up this whole section and start over and do it. Listen, even the professionals are making weird mistakes. Like, look at I don't know what layout software they have, but whatever they're doing over here, they traced it out from this pad, dropped it on here, and then had a different size trace go across. So this is a holdover from the CAD software having rounded trace layouts. That's crazy. All these little things that you see. So don't beat yourself up over circuit design. Not everything is completely perfect, and even the super duper professionals over at Tektronix are bodge wiring their way into a functional circuit. That one actually looks like it should be there. Oh no, never mind. Going all the way over to here. I guess they didn't want to take the trouble to actually run the wire. I don't know what the hell's going on. This is like eldritch horrors beyond our reckoning. This is beyond what human beings can really understand in this world. Some kind of an eldritch deity with neither a care for our own personal safety. Other than that, it's a pretty good board. It's not exactly going to win an award for layout, but everything is spaced out, and they've got... It's just that same size trace thing everywhere. It's kind of crazy. This too. Yeah, I guess would this be a matter of like running an equal length to all of your devices? Why would it be H'd in the middle like that though? Is it the beginning of some kind of a measurement that you're amplifying? This would be a precision resistor board. These are crazy. Wait, oh, is it on this side? Oh no. Weird. So they're sandwiching the resistors between two sheets of FR4, which is kind of neat. Sacred mysteries. Yeah, this part is being kept secret. It's probably just a precision resistor board. So whatever we're doing over here, it seems like everybody has been matched together. So they probably get the yellow marker for having certain properties. And so when you put all these transistors together, they would be close to super matched, if not, probably not super matched. The advent of super matched pairs would probably replace a lot of this part of the circuit design. The super high precision resistors and the super matched transistors. Later on, there would be a family of devices for both RF and instrumentation, and turns out oscillators on music devices that would have what are called super matched transistor pairs. So it's practically like having the exact same transistor twice. Whereas back in 1988, which is what the circuit board, before I ruined it, told us the year was, back in 1988, you would put these into a transistor tester, and if they had certain properties, you'd put them in a bin with all their buddies, and you'd label them. And then when it came time to actually build this, you'd use all of one particular color. It's a biblically accurate circuit board design. Ugh. It's funny, I guess whatever program they were using was running on 1980s hardware, if not, I guess not hand-drawn. It probably isn't hand-drawn because this is very CAD software-y, these grid holes. So what ability would they have to, for instance, even out the length of traces and stuff like that? They probably wouldn't have the capabilities to do stuff like that. In the late 80s, I was 5 years old. Yeah, so cool. Some neat stuff going on in here. Also some really disturbing things. Some of this stuff is really disturbing. This software would probably let you have two traces just crossing one another, and it wouldn't tell you about it. That's what the old PCB 123 software was like. I had a trace that ran horizontally on the wrong layer, and it practically destroyed my entire design. Well, that's pretty cool. Cool stuff. No Easter eggs, though. That's unfortunate. That's almost against the law. Like big coils or something. Of course, down here, it's all just that stuff. So those two posts are these here. I guess this is just like a plastic weld or something that's holding a giant post in place. All right, well, before I forget how this thing goes together, we should probably put it back together. I can't believe the 88 lifted so easily from the circuit board. This must have been like an early version of this type of printing technology. And my soldering iron was just too much for it. Because like the PCBs like following this, and some, I guess they're not 80s. I guess the 1990s circuit boards that I have are fine with the soldering iron. But this immediately lifted because of the heat. All right, let's put it all back together. It all goes back together. I gotta figure out which things go where, which connectors, and whatnots, and what's its, and howdy doos, and thingamajigs, and neat stuff though. Neat to look at. Old school through hole design. Why is that cut out like that? They probably used this shield in a couple different pieces of equipment. I wonder what RF stuff they had back then. Like, this probably is not the highest quality that they have in circuit board design. What was the level above this thing? 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 What was the Maybe they had shiny solder mask on it. That solder mask is bad. It's really bad. It's abysmal. Wait, there's just one big old through hole sitting out in space over here. Weird. All right. I guess I don't want to use the auto screwdriver on this because I could probably hurt stuff by over torquing. Not like they don't have enough threads in here. Jeez. It's like 60 turns to get this thing to go halfway in. There we go. Hope that person that I sent those STLs to makes some cool blower for their 3D printer and gets back to me about it. Because that's what I want to do. I just don't have the time. Minimizing leakage currents. Then the star thing. Yeah, weird stuff. I mean, this is like... I don't know if this entire thing was hand-assembled, but it might have been mostly hand-assembled. Well, no, they clearly used a wave soldering machine to do most of this. Because of the way the text is filled in. Then... how did this thing fit on? What do we do there? Hold on, I'm using my brain for the first time. Oh! That second piece goes on first. My hand hurts from screwing things. I can use the other hand. As is tradition. Yeah. Order of operations, fail. So do we think anything's going to explode when I throw this thing on? I don't think it will. I want to look at that last module, and then we'll be able to power this up if I can find a plug for it. That'll complete our inspection of at least the modules. The back end, I haven't looked at on either of them. It looks like it's going to be tough to get into the back end. It's much larger than my my workshop bench. So these are kind of offset from one another. So this should only fit on one way. And since it's rectangular, well, there it is. That's how it fits on. All right. And there it is. I don't want to scratch this stuff up, but it's going to end up getting scratched from all of my mishandling of it. I guess this goes on top of the aluminum. It doesn't slot into it at all. And this one will align it. There we go. Got this old electronics and the gunk that they have on them, all the oxidation and stuff. My hands are very dry as a result of handling all this stuff. Which I guess is good because I'm not leaving like giant moist fingerprints behind me. But I'm really going to have to wash my hands after this. They're going to be covered in weird crap. Who knows what kind of chemicals lurk within? So many chemicals. God, my hands are dead. This has been a lot of hand screwing going on here, and I don't trust the auto screwdriver because we don't really know the construction of these things. We don't know if it can handle the auto screwdriver's sudden influx of torque. Torque! Careful not to bend these too much, even though they are braced against the jacket, which is very nice. Oh, next piece is this whole bottom sheet. So I'm going to put this back in the right order. Leave it like this. It's pretty wild how this is all modular. It just kind of all fits together with itself. And then if you decide that you want to build a different piece of test equipment, you can get these panels. I don't know if I'm guessing you can buy the panels. Put together your own little research thing, and I'm sure people have in the past, depending on what, you know, the application is. I guess if you've got like a big, you know, if you're running a big piece of equipment or something, like a radio tower or something, you can probably piece together your own rack mount equipment using this stuff. You know, semi-permanent installation of a customized measurement equipment. Of customized measurement equipment. I've seen it before. It's always fascinating. This is like loose fitting. I don't know if that should be so loose fitting, huh? I suppose so. You know, maybe at some point I get smart enough that I need to build my own. Even if I did need to build my own rack equipment, I don't think I would use this stuff. But I could gut these things and use them sort of as my own card edge connector. I don't need big equipment like this, though. I'm not running a satellite array. Would be pretty cool. All right, bring back in this one. So it was red, orange. Actually, down here is white on this one. I mean, you can almost tell from the way they're bent which one is connected to which, but okay, that one there. The next one is, yeah, see, look, that one even just found its way back to the right plug. Oh, and these are gold plated. That's nice. That's nice. That's nice. Who's next? Gray. This one. And then orange goes all the way over here. And then red goes here. It's like I can't really trust this thing to give me accurate readings. Might have been a good piece of equipment back in the day, but nowadays it's like I can get like a $10 multimeter and it'll do better than this. It goes here. And then the back, the rear connectors we can put on now. And then we'll kind of wooble the whole body together. So this goes over here. This way I'll make sure that I don't plug this in like my musician friends plug in their IDC cables. They plug them in wrong. And they blow up their devices. And they bring them to me. And they go, please, sir, my son is very sick. And I go, application denied. We gotta fix those 303s. Those have been in the shop for way too long. Those poor 303s. I can't get them to output hard enough. They don't have enough like volume on the output. I suspect one singular op amp is to blame. Both 303s are doing the same thing though. They're both exhibiting the same behavior. Which is an odd behavior because people generally describe them as being blown up by being plugged in wrong. You know, obviously. They blow up when they're plugged in wrong, and the fix is so standard that I have a document that details all the parts that I should replace. On replacing them, both units exhibit the same sort of failure, which is just a failure to output enough volume on their outputs. Everything else seems to be operating okay. The diode ladder circuit works okay. All the other stuff that I can test appears to be functionally just fine. So maybe it wasn't mentioned in the repair document that this other connection can go wrong, but it appears to be, this other chip goes wrong, but it appears to be a problem with both of them. So the logic center of my brain is saying that you know, if I can knock out the one fix, it'll fix both of them. Maybe it's something that just hasn't been gone over in the community. Do wish that I could get into contact with the creator of the device, but I guess they're so far out of the game that they don't check their email anymore. That's tends to happen with old devices. This went back together way easier than it came apart, I'll tell you. This is going to be the hard part, is getting these pins in without damaging them all. Since they just go into an extrusion, it's kind of a rough connection. Arc, arc. Actually, I do think you could buy these panels. I think I saw them listed somewhere. It was like, I was browsing like DigiKey or something, and I was looking at test equipment, I think, and I came across like just the generic panels you can buy. So like if you wanted to make your own custom piece of electronics that would go into this big rack system, you know, and get power and be able to cross communicate with everything for like a custom, I don't know what you would be doing, like if you had like an optical table set up or whatever other kind of like design and electronics research you were doing. I think you could put together your own custom device. Which is kind of cool. That's kind of cool. That'd be pretty badass. I'd probably just put my stream computer into one of these things. Just have a bunch of your stream computers in these things. You'd have one that runs your VTuber model, etc. Have little those little cutoff connectors in the back for water. So you just build your computer inside the little case, have a hard drive connector in the front, and then water connections in the back. That's way over that. I wouldn't do that. It's so over the top. It would be cool though. Plug them all in, get all your I/O on that. Your whole stream setup is just a piece of rack equipment. That's very stupid when you could just have normal computers that are easy to work on. I'm in the brainstorming mode at the moment just because I'm sitting here screwing things back together. But this one at least revealed to us the date. It was 1988 when all this equipment was procured, or at least when that circuit board was made. And I don't suspect that a circuit board like that would be sitting around in an assembly area too long. You know, it could have been as late as 1989 that they got all this equipment, but it probably was more closer to 88. It smells like 1988, which you typically assume to be cocaine, but no. Ugh, jeez. Now, did I put them on the wrong side? I don't think so. I'm going to double check that real quick, now that I've done all that work. I'll check YouTube to see if we've got... No, Phoebe was commenting on YouTube, so YouTube is still active. It is just a very quiet Thursday. Yeah, there we go. Okay, so we've got all our messages on here. Just got to check on my equipment every now and then because the stupid YouTube / Twitch combination chat thing relies on Chrome, which will power down your windows that are taking up a lot of memory. The pins are on the bottom. I put them on the wrong side. I put them on the wrong side. Can I get it right just once? Just once? Just once. Nope. No can do. I can't go for that. I'm not a gopher. No. No can do. These are wrong. These are wrong. They're all wrong. They're all always wrong. The top of the board is on the other side. The pegs go on the bottom. The pegs are there just so that your card edge connectors don't smash up against something. But it would be kind of cool to come up with our own, like, lab device that we would need to build. That'd be kind of crazy to do. I think, who did that? I think it's the guy with the beaker and the wrench as a logo who does all the scanning electron microscope stuff. Applied Science. I think Applied Science has done stuff on that level. I think in order to satiate my desire to have sort of high level scientific equipment and build it, I think I'm just going to play Voices of the Void. And then that'll sort of satisfy that sort of need to mess with high level scientific equipment. That's why the pictures on my phone are just things in the sequential state of disassembly. Yeah, phones have really helped with that, like in a big way. We used to have like Haynes manuals that would say assembly is the reverse of disassembly, and you're looking at all the pieces of your car, all the little bits and bobs that you've stashed all over the driveway, and you're going, I don't remember that. I don't have that kind of institutional memory to remember where all of this stuff went. You put it all back together and you go, oh, I guess I've got a couple spare parts, and then your car explodes. That was the traditional way of doing stuff. Now we've got phones and tablets, and so we can take a picture of everything that goes together. We can even take little videos if you want, or you could look it up on YouTube, and somebody surely will have an instructional guide in video format. Even the forums weren't superior in this manner. In the forums, you would have mistakes that people weren't able to edit out. You would have procedures that were just done pictorially, picture after picture, and you can't really get a good idea because the person who's doing it can't write properly. They don't know how to do technical writing to instruct you on how to do things. And it could be a mess. There was a lot of really good stuff. There were a lot of really good instructional tutorials that existed only on forums at the time. But YouTube has sort of taken up the mantle on that one. And now when you're working on like a car, you can look up a video of somebody doing the thing that you want to do, and you can figure out how they contorted their body in such a manner as to reach the bolt at the very back of the engine that they literally, in the CAD program, they had a blank document. They took the bolt and they dragged it onto the screen, boom, and it appears in the design, and they designed an entire car around it. You can see how you're creatively supposed to get to the sword and the stone bolt that holds your whole car together. Almost got a scanning electron microscope from public surplus. That's pretty crazy. Still regret I looked away 2 minutes before and it ended and got snipped away from me. Nobody had bid on it but me in the last minute. Did it go to Applied Science? Is that who sniped the scanning electron microscope from you? There's a couple like that, oh man, I don't even want to remember them. I don't even want to remember them because some of them are like, industrial robot arms and cool stuff like that. At one point, I was bidding on a Mateba auto revolver, which is a very kind of unicorny gun that it was in Ghost in the Shell. It is an Italian revolver that sort of the whole top of the revolver slides backwards, and so it goes into whatever cocked state so that you can shoot again. And this was the carbine version of it, and the auction was at like $5,000, and I was bidding on this thing back when I had a job and I had a little bit of disposable income, but not quite that much. That much money, I was like, I could make that happen. I could really, I could shuffle some things around, maybe borrow from my parents. If I had gotten that thing, it's probably worth just an absolute mint these days, because that stuff never knows. Those never go down in value. They only go up. I know exactly which gun that is. They were selling, it was on Gunbroker like 10 years ago. Somebody had the carbine version of it, which means that it just had like a rifle-like thing, a rifle-like butt. I wanted to get one of those. I got one of them, what do you call it? The two unicorn guns that I think I'll probably never own, and I should have bought in the 90s when I was a child, was the Mateba auto revolver and the Medusa. The Medusa is one of those engineer finds a problem that's not actually a problem, because when you're at the range, you should be practicing for the caliber that you want to shoot. But instead, this engineer went, I like to shoot a bunch of different calibers. I don't want to bring a bunch of guns with me. I want one gun. And so they decided to use really good metal on that one gun, and they were able to actually have a revolver that could chamber multiple different rounds. That one is featured in, was it Die Hard? One of them movie bad guys had one of these things. It's basically It looks like a revolver, but the barrel has kind of a squared off top and bottom. And apparently the ejectors on it are irreplaceable. The thing that ejects the rounds when you push on the little rod of the cylinder, those are apparently extremely flimsy, and they're irreplaceable. You can't get them. You could probably make a press that makes them, but still, I wanted to get one of those. It would have been cheaper back then. They sell for God knows how much because you can't find them. I don't have the money for that sort of thing anyway. That's a little bit bent out of shape. I could fix that, but I probably shouldn't. I don't care. One gun to rule them all. That's such a weird concept, and I think, yeah, it was Forgotten Weapons kind of made fun of it, where it's like you're at the range and you're looking at the bottom of your bag and you got a bunch of different calibers. Now there's a solution. It's like such a weird thing, but I love how kind of strange it is and sort of engineer brain. You know, it's engineer brain rot. This is a problem. It's like, no, it's not. It's not a problem. It's not actually a problem, engineer. You don't need to fix that. Yes, I do. I need to fix this problem. It's a drunk project that got out of hand. Yeah. I didn't make a gun. They can shoot whatever bullet. Because what if you could just squish a bullet into the barrel? These calipers are kind of the same. And then the reason it's such a unicorn, aside from that, is that the extractor has to extract both rimfire and traditional cartridges or whatever, semi-auto cartridges. Join midstream. What is this device? So this is a Tektronix TM5006, which is a big old school piece of lab equipment. I got two of these things. Apparently they're pretty modular. You can kind of make custom modules for it, but what you can also do is slot in all of your digital, sort of early digital age tech equipment. So this, what we just looked at, was a digital multimeter. This is a variable power supply. You can connect GPIB to the back of this thing and have these kind of go-to automatic settings that you would set out with some kind of communications protocol. So they were good for labs. They were good for setting up a lab and doing a test that you would do multiple different times. So if you were like doing some advanced electronics stuff, I guess you could set up a test routine and you could possibly even control that digitally. But they're totally useless nowadays. We have Arduinos and we have, our digital electronics are much more capable than what these things can provide us nowadays. Like, this stuff was expensive and it was calibrated, but it was expensive and calibrated last in 1999. Of course, I'm driving a car from 1999, but that's different. I need to get my car registered. My car is not registered, and I need to go to CVS today. So I need to drive out to town, and I need to not see any cops on my way. My road here is fairly popular with the police. I'm going to fucking get pulled over today. I just know it. I'm going to get pulled over. It's going to happen. In my 1999 station wagon. You see, the 1999 station wagon is also a cloaking device of sorts. It is completely invisible to the police. I could be murdering people while going faster than the speed limit, and they wouldn't notice. Oh my God, this thing could light up? No, there's no window in the back. What in the world was this? Components can be installed internally. 40 volts max. Ground selector. 40 volts. But it was the power supply is only 12 volts in the for the outputter. Is that X-ray? No, it's not X-ray. Some other form of Pig Latin. Just print out something from the DMV that shows a date, something to use as evidence that you're on the way to the DMV to fix the issue if they pull you over. That's a neat one. I have done it where I've driven by the cop and I immediately go onto a side street and ended up finding a parking lot, parked, got out of my car, walked up to the building that I didn't have access credentials to, sat on the bench next to the front door, and watched the cop drive by on a side street. And I was like, ha ha. That was definitively running from the police. I won't tell you when that happened so that I don't end up getting arrested. My first year of college studying electronics and automation. I studied control systems in electronics at Drexel 1,000,000 years ago. I need to get in here in order to clean this thing out. This stuff is clean. It just sat at the bottom of a shed for 10,000 years. What's up, Zorthrex? Maybe if I do one of these where I hold on to it, push it in there, work it in there. Yeah, I don't know if this is custom. Oh no, it's not. AM501 operational amplifier. So if you really want an op amp, you can install this giant piece of equipment that's essentially an op amp. Why would you do that? Can I not just go get an op amp and put it on a breadboard? Into physics, all right. Well, there's a lot of physics in electronics. Yeah. The initial question was, what do you do? I'm a clown. I am a clown, and I clown. That's what I'm doing right now. I'm clowning. That's essentially what being a streamer is. I'm just a big old clown for you guys to clown on. We had some foreign language speaking person in here who was doing their best, but when I said the word clown, they had a little freak out session, because I guess the connotation is much different nowadays when somebody calls somebody else a clown. Calling yourself one was even more insulting, apparently. Clowning is the ancient and venerable tradition. Yeah, there you go. Rodeo clowns, you got birthday clowns, you got people on Twitch who believe that they're not clowns, and they're wrong, because that's exactly what I'm doing right now, is I'm sitting up here and honking my little honky nose in order to entertain you. No bother remembers when they invented electronics. I've actually, I've been around a lot of very old electronics throughout my days on this earth. Just because I cleaned out an old University of Pennsylvania lab where, I don't know, they invented electricity or some shit. Ben Franklin was sitting in some stool and he's like, man, what the fuck? And then he invented electricity. No, it was Dr. Britton Chance who did a lot of really crazy shit at the University of Pennsylvania. A lot of bioengineering and the like, but there was a lot of very old equipment around, including some of the first digital storage devices, which included a floppy disk drive where the floppy disk was this big and the whole thing looked like a giant panini press. You would pull down a giant lever in order to close this thing. Chunk. It was crazy. Problem with electronics is I dislike some devices such as phones, TVs, or others, but I'm interested in the electronics of satellites, rockets, and others. Do you think that's a side effect for me? I don't know, man. I don't know what to tell you, dude. You can go into those disciplines if you want. You just gotta do the work. Patent pending from Tektronix, huh? This is Tektronix made this? What the fuck? How much did this thing cost? AM501. Let's look that up. If it doesn't have vacuum tubes, listen, one of the spaces that I was cleaning out for a summer job had all of the parts of ENIAC in it. They were a bunch of cardboard boxes that had vacuum tubes and wires. And I'm like, what's this stuff? And they're like, that's ENIAC. I'm like, oh, one of the first computers. Cool. Why didn't I steal any of it is beyond me. They all went to like a computer museum. AM501. We used to have a, it's a flight from Mexico. Tektronix. 5 megahertz operational amplifier plug-in for the TM500 system. On eBay, they go for no less than $668. What? Oh, that's better. That's $30. There's no way. I love watching my electrical engineering court jester. Ding-a-ling-a-ling. Look at my keys. I can't believe that guy yelled at me for my own like self-denigrating humor. It's like, come on, man. $668. No interest though if we pay if in full for 6 months. Probably around when I stopped watching your streams, I disappeared from the internet when I was going through all the ADHD medication suffering. That's a tough time when you have to try to figure out what the right medications are. Yeah, wait, hold on. There's more to the story. I need to like scroll back and get the whole messages. What I was going to say before I left, I used to watch, I used to want to be a gunsmith, so I have an excessive amount of firearms knowledge. Oh man, amateur gunsmithing. I guess I could do that with that mill, but the pressures involved are a little bit serious. Okay, there's a message between here, and I missed one. Hold on, let me find it. Gunsmithing, and then I don't see a message in between. So it was so gunsmithing, but then I quit my ADHD meds because they were trying to kill me. I learned my emotions were blocked for almost 20 years, and I had to relearn how to feel. Wow, that is a weird byproduct of strong ADHD meds. Didn't want anything to do with fixing or selling guns. Disappeared from the internet, and then yeah. So you're here on the other side, able to be a real person again, which is, hey, it's good to hear. I'm glad you did okay. Didn't know you were going through it, but I would have been on your side. That sounds like price gouging. Like technical equipment can suffer from that kind of stuff. Like you can get something that's not really worth all that much. I think this one might have been at Drexel University because I think I have the temperature. I think I have the probe for this, but I don't have this. I think some of the other equipment had this, but if I wanted to buy that, it's $300. Even though this is from the late 80s, early 90s, and it is probably a pretty useless piece of equipment. It's not calibrated, there's all that. You need to have the specific rack mount test system in order to even run that thing. Although I might have one of these. Actually. I have to look at all the stuff that I've got in the back. I think because my buddy had a bunch of these things, a bunch of these big rack things. It's a shame they're not a little bit more universal. But I guess if you had like a more specific test that you wanted to run, this would be a nice modular system where you could have something that lives in sort of a rack and you've got to calibrate and blah, blah, blah. A friend of mine bought a limited $30 quantity, a $30 limited quantity spider plush, and someone is selling the same plush on eBay now for $250. It costs very little to list things. I guess you list it at the price that you would be willing to let go of it for, and then maybe some sucker comes along and buys it. I know one of the things that my buddy got from Drexel was like a prism, and it looked like it had rolled down a hill. Like it looked like it was in terrible shape. But the bidding war started, and it ended at $600, so he was pretty happy about that. This is an operational amplifier. What the hell's going on here? This is a lot of stuff. I mean, what did they do? Did they build an op amp out of all this crap? And it's very old electronics. But this is supposed to go up to 5 megahertz, which is laughable. It's just laughable. Did I use these in any labs? I probably did use them in labs, but I was too pot-headed to actually learn what I was doing with it. So at the back of this singular op amp, we have 2 op amps. Plus adjust, minus adjust. I guess that's positive and negative power. MC1741C. Hold on. MC1741CP1. I don't think I need that whole part number. Data sheet from On Semiconductor. Is this just a variable power supply? Internally compensated high performance operational amplifier. That's all it is. It's almost always better to go into eBay advanced search and look up things for the price they sold at. Yeah, you got to look at the closed auctions. It helps immensely with figuring out if you're getting fleeced or not. So this is a singular precision high frequency op amp, high performance op amp. Why would you not just go get one of these and put it into a breadboard? Well, it's probably, you probably can't buy them anymore. But nowadays we have better ones anyway. Shopping? $2. $2.80. $15 maybe. You want to get the old style, it's $2.90. Just a massive amount of capacitance on this thing too. Is there a date code? Copyright 1972. Tektronix Incorporated. All rights reserved. Okay, so this is 1972. I don't know if it is. It doesn't really look like 1972. That seems like a little, maybe the circuit board was, well, it was drawn by hand. There was no CAD well, maybe there was a CAD program involved in this. These traces just look very much like hand-drawn traces. Everything is a curve. This is crazy. What a bodge wire. Oh my God. It's a bodge wire job. There are some crazy traces going on here. This just op amp. And then I don't know what's, like, what in the world? Why would you have all of this coil and resistor and diode stuff going on here? When your base device is just an op amp. Did they create, do you think they built an op amp? Like the, you know how you see the circuit drawings in the data sheet? And sometimes they break it down into transistors and resistors. Maybe they built an op amp that way. What the heck? Null offset, or offset null. Hey, how dare you call me that? Rude. It's just rude. It's just a rude circuit board from 1972. Output negative and positive going on these giant rails. What look like some kind of a surface mount thing. I don't know what this ground is exactly accomplishing here. It really does look like they're trying to, like, surface mount something. But it also could be that, no, they're not. It wouldn't be. Building up like a capacitor out of circuit traces. You see that on like oscilloscopes. You don't really, like, an oscilloscope does that. Not a weird 1970s operational amplifier circuit. The board is copyright 1970. I wonder though. This doesn't feel like 1970s era technology. This feels a little bit more 80s to me. Pretty crazy how you access all the stuff on the card edge. Man, we could come up with something. We could build our own thing for the rack. It would be a pain in the butt though. I've got enough on my table right now trying to build a modular synthesizer testing module. How does this stuff compare to modular synthesizer stuff? Like the size of the board. They're like similar properties. Oh, okay. Well, that's close. I think that might actually be the same stuff. The same dimensions. Only this one has a series of like troughs in the rails. What is this out of? What is it called? TM5006. It's a Tektronix rack mount test setup thing that has these modules that plug into it. They've got this little pull cord to undo, to kind of undo the lock, but they lock in on the rails and plug into a card edge connector at the back where it distributes all this stuff. Yeah, I used to reverse engineer IEDs. As a contractor for the U.S. government. Whoa, 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 whoa. Whoa, 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 whoa. Whoa, 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 whoa. Whoa, 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 whoa. Try to bend that back into place. Tell me what's the electronics inside of what? An IED? I think you can probably answer your own questions in terms of boundaries on this stream. Twitch streamer tells audience how to build bombs. There's a headline that I never want to see. And I never will. Well, unless it's not me. What's the module itself? Ever heard of an operational amplifier? This is what it takes. Have you ever used an operational amplifier? Did you know that this is an operational amplifier? This is what you've been installing into your electronics. Irresponsible. You should know what. Respect your elders. You see this right here? This thing right here? This right here? This is an op amp. But this is an op amp. This is apparently this is an operational amplifier plugin that you can use in your lab to do operational amplifier things. Up to 5 megahertz in frequency. But an op amp basically just compares two voltages and outputs with a certain amount of gain. And the operational amplifier typically has a gain of something like 300, which is a huge number. So you loop it back into itself, because an operational amplifier typically inverts depending on how you wire up the amp itself. But with an inverting operational amplifier, if you have feedback coming into your input, then the output can cancel out the input to a degree, and you have an adjustable amount. You have a certain amount of gain that you get out of your circuit. So you're inverting your signal coming in, but you are also applying it to itself in order to lower it and get it into a certain specification. So if you want to amplify a signal, you can use it in that manner. You can wire it up a little differently, use some capacitors, and you can get something that will integrate so that you can get a pulse when you get a certain amount of signal. There's just all kinds of like mathematical functions that you can do with an op amp. And so this, I suppose, would be an op amp that's a little bit more catered towards the lab setup conditions. So if you're testing a particular thing, or you have like a temperature probe and you want to invert the output, you could plug it into something like this. Or if you've got too much gain coming back on a sensor, you could plug this thing in and maybe lower the amount of gain on the sensor. I don't really know. I have a feeling there was an intro to op amps class that we had that used this instead of a PCB, and we had to hook it up and, do all that. Basically just follow what's on the sheets, don't learn anything. I hated labs like that. I always loved labs. I was always very good with the lab stuff. But doing a lab that's just regurgitation of values is next to useless for people like me. I am not one of those book learners. I gotta do stuff in order to learn. So that's what that is. So I need to find a power cable. I need to find a power cable. Yes, sir. And we power this thing up and all the capacitors charge in perpetuity. A varying series of explosions that we get as a result of powering up something so old. I say that, but my car is from 1999. This thing is from like 1988, somewhere around there. Although this specifically is 1972. So we've got a hodgepodge of devices here. Tech AM501, manual schematics there. Yeah, that's what it is. I mean, what's the manual going to tell us? That it just contains an op amp. It's so weird. Why does it contain an op amp? I think they use these with the temperature probes, and I have a couple of those in the back room. Caution, turn the power module off before inserting the plug-in. Otherwise, damage may occur. I mean, it does all the jobs that an op amp does, only you've got like a fixed power supply on it. Ground selector. Alternate input in B and C. Yeah, it's a lot of switching stuff. But like, there's a lot of electronics to do this stuff. There's not really much to the manual, huh? I think we use them in conjunction with temperature probes. I think that's how that lab went. This is not the kind of op amp you'd use in an audio application. I mean, you could make it do audio stuff. We made it do, I think, temperature sensing stuff. But yeah, you would be taking in like high frequencies to this thing, right? Oh, this would be a power electronics kind of thing. Weird. Warning! The following service instructions are for use by qualified personnel only. To avoid personal injury, do not perform any servicing other than that contained in operating instructions unless you are qualified to do so. Oh, here we go. Points 1 and 2, installation of bandwidth limiting capacitor. Positive test supply points. Pretty cool. Positive, negative adjustments. What are the regions of this? What are the regions doing? They're not really explaining. Like, I don't got to explain myself to you. Jumper across pads for appropriate connections. Okay. Repackaging for, circuit description. Oh, here we go. This section of the manual contains a description of the circuitry used in the AM501 operational amplifier. Individual descriptions are separated into following parts. Okay, so general operation. AM501 is a feedback amplifier having low output impedance, high overall gain, high output voltage, current capabilities with excellent stability. So it's a high current kind of thing, yeah. Maximum safe differential input voltage is 80 volts. The high gain section of the amplifier consists of the input FET and current sources, the output current sources, and the output current sources. The output current sources serve as high impedance loads for the FET. The gain is GM R0, so G times R, where GM is the transconductance of the input FET, and R0 is the impedance of the feedback amplifier. Transconductance is something that I'm only just recently learning about. I didn't know anything about transconductance, and now I'm using 2 transconductance amplifiers in the mixer that I'm making. I didn't know that existed at all. The output stage is a unigain amplifier having high input impedance and low output impedance. Okay. The output stage is capable of plus minus 40 volts. That's an 80 volt overall differential at approximately 50 milliamps. So we're not putting a lot of ass behind it, but we definitely have quite a bit of voltage. Yeah, it's a highly tuned op amp for high voltage applications. So you're not going to be doing like significant work with that high voltage, but if you have some kind of like a system that uses high voltage for what? Like what would you do? Because 50 milliamps, you're not running motors with that. I'm not doing a Jacob's ladder with this thing. Input FET uses a conventional current source that provides constant current determined by the blah, blah, blah. The source drain voltage input of the FET main. Oh boy, this is getting very deep into the circuit. The overview stuff was pretty much what I was interested in. Conditions that differential characteristics of components are balanced using the offset null control. So that's what that other knob was. I have a feeling that there's a big schematic coming up. There's a big schematic. There's a big schematic coming up. Diagrams and circuit board illustrations. Oh, here we go. Hey, maybe they'll have a slightly better, oh man, this is, 1970s. Cool, cool. What is the purpose of the giant pads, though? Oh, dear God. I'm not going to start in on this. Grand selector. Oh boy, talk about, it's not so bad. I don't want to get into that though. I would rather they just describe the different areas of the circuit board and what they were doing. Oh my God, it's all the diodes. They've gone crazy. It's a full bridge rectifier, but in a very strange manner. It is a very strange way of drawing a full bridge rectifier. So the rectifiers go into op amps that I'm guessing are just stabilizing the voltages, and then that goes into power. Replaceable mechanical parts? Nah. Wow, this thing, like, they give you all of the information about this thing. Pad purposes on 23. I saw that they had jumper stuff, but maintenance troubleshooting. Make connection to the operational amplifier through the front end binding posts, BNC connectors, or the rear interface connector. The rear interface connections are not factory wired. For suggested pin numbers and functions, pads are provided on the circuit board for the pins shown. So the pads are just for testing purposes? A barrier inserted between pins 23 and 24 on the power module will allow the AM501 and plugins compatible with it to be inserted in that compartment. See the power module main from what the fuck? 4.2 shows pad layouts for internal component connections. Any combination of resistors, capacitors, or other components may be soldered to the pads as required. Jumper from the input, output, and ground connections. Label on the board by the appropriate pads if necessary. Remove the wires to the front panel connections and reconnect them to the pads. Are they just giving you like a big area to connect pads? That's strange. Yeah, it's unfortunately part of the reason that I isolate myself from other electronics channels, and I haven't done a great job of that, but I don't really watch like some of the big YouTubers in electronics because I don't want to bring in their memes. I want my stream to have my personality on it. Even this could be considered a bit that I stole from Sark. If I did one more Zoom level, it could be considered to be stolen from Sark. I probably got it from somebody else, but still. I don't want to like just do full bridge rectifier like Electro Boom does. I want to have my own personalities, my own memes, because I'm a funny guy. I'm a funny guy. But yeah, I've failed in a couple respects, and I even caught myself doing an AVE-ism earlier, even though I think he went off the deep end after COVID. So, I mean, are these just giant pads to solder wires to? Do they not trust us to be able to solder wires, that we need to have an area that's the size of like a planet to put wires on? Yeah, it's like this weird like pre-surface mount breadboard area. Strange. What, Sark most certainly stole it from me? Probably. I don't know. I've been watching Sark streams lately. That man runs a good stream. It's a fun stream. Usually it's on like another monitor and I'm working on stuff on the computer. It's so you can breadboard something to it, close it back up, and there's your test bench. That's kind of weird. I mean, like, even back then, proto boards were a thing. I guess they didn't want to drill all the holes for like a prototyping area. But again, we took apart another one of these modules that has this huge prototyping area on it. Yeah, 1975, 1974. I guess. Yeah, you're not wrong. None of us are wrong. None of us are correct, but also none of us are wrong. It's just strange. It looks like what it looks like to me is what they do with oscilloscopes, where when you get to the high enough frequencies, putting traces on a board can net you actual like picofarad capacitors and certain value resistors and stuff just by the way you shape these traces. There was a website that showed all of the different shapes that you could build on a circuit board in the copper layer and the effects that they would have. I lost it. I don't know what happened. There was a link from Reddit, and I clicked on it and I said, that's so awesome. Read through the whole thing, closed it, never found it again. I gotta find that website because it's awesome. It's also something that I need to keep in the back of my mind when I do trace layouts on PCBs. Is, hey, does this look like a capacitor? Because that could be at high frequencies, it could accidentally be filtering something. So I've seen circuits from the 70s that were hand built where they would take the Radio Shack copper-plated FR4 boards and they would literally just like carve their circuit around and they would mount everything to the surface instead of drilling through. I've seen that. I've seen that from researchers. So I guess in lieu of that, you could also use this little pad right here in order to build whatever little custom thing you needed in order to do your research with. So that seems to be what it is. And then, push comes to shove, you could buy the panels for these and make your own front panel and have it slot into the rack and do all the things that these do as well, which is pretty cool. Or you could hook it up to the big front connector. One of these modules here with this big front connector is actually just the big proto board inside. So you could build it inside of something like that, and then you could have your A to D, D to A, et cetera, et cetera, et cetera. Or you could build your own entire cabinet. It's crazy stuff. It's for like, these were probably a big deal back in the day for doing like, if you're a company that's building like an electronics thing and you're part of their like research and development, or you're a scientist building something that needs to measure something custom, this might be where you go to build those custom circuits. But Boy, they are useless for us because we're here in the year 2025 and we can buy a $10 device. I have literally a $10 oscilloscope that would do better than those things. I don't know where it went. Where did it go? I have the parts for, no, that's not. It's around here somewhere, and we got to build it eventually because I want to make it into a module for the module synthesizer. Just a little cheapo oscilloscope module. And I said I'd power these things on, so I guess I probably should power these things on. I need to find a power cable, which may involve spelunking a little bit. Where is my big power cable? Well, I know the steering wheel project has a big NEMA connector. Luckily, these things use NEMA connectors. I don't know how old the NEMA connector is, but they didn't have to use that for the equipment here, and they did. It's nice of them. But do I have a spare NEMA connector? Not likely. Oh wait, I know where there's going to be one for the power supply that I bought, and I still haven't put that power supply in my computer. I'm kicking myself about that one too, because it's like I bought all this really fancy hardware for the computer, and I'm underpowering it. I've got a 750 watt power supply on it. It needs probably like 800. 750 gets me by, but I've disabled a lot of the functions that allow it to kind of kick up its super duper effects, whatever the AMD stuff is for the processor and the graphics card, so that it doesn't kick up the power and then end up restarting the whole thing, restarting the whole PC. I want to enable all those features again though, so I bought a 1000 watt power supply and I have it sitting on this rack mount drawer. The rack mount drawer, I want to move all of my hardware over to this thing because eventually I'm going to have rack mounts on the desk itself, right? So if I do that, I can get all the water cooling stuff together and actually put it in the right order of devices so that bubbles will find their way to the reservoir for once. My current computer setup, the super duper mutant computer that unfortunately I can't show you guys it right now because there's a box with my address on it sitting right next to it. Wonderful ways that I organize my lab and completely dox myself just by moving a camera to the wrong spot. I missed 3 hours ago Celia gigantifying an remote. Anyway, the computer setup in between the two radiators is a piece of acrylic tube, the typical water cooling acrylic tube. Bubbles will collect in that area, and I have to pick up my whole computer and shuffle it around in order to get the bubble to come out. Very, very annoying. I think I need to use larger tube so that it can properly get the amount of flow that would punch a bubble out of an area. And then I also need to reorder the order of operations of components so that a bubble will naturally find its way to the reservoir. The reservoir needs to be above everything else, and the pump needs to be below everything else. Pump at the bottom, thingy at the top. Oh my God! These things probably have a giant transformer in them. I'm a little bit concerned about powering this thing on, but I'm going to do it because I said I would. But there is a huge piece of metal in the back of these things. Makes it very, very heavy. I could probably take the top off of this thing to take a look at it. We should do it without that. We should just power it up. Because it's a little bit more psycho than just, jeez, fucking hell. Okay. And this is a power plug for a 1000 watt power supply. So whatever current this thing is drawing through this NEMA 23 connector, this plug can handle. Make sure it's off. It is off. Powered off. I'm going to plug this thing in. Please don't short out everything. Okay, so far so good. Oh, there's a lot of noise from the fan on this audio line. Oh, why am I on that channel? Huh, weird. I thought it was the other channel. Okay, is everybody ready? There's like 4 people in the audience. Let's see if this stuff works, or if we get a variety of different blue smokes, or a variety of different blue smoke from various eras of electronics out of the back. Oh my God, this thing makes a real power-up noise. See, this is what I'm talking about right here with the blinking lights. Love the blinking lights. Inst ID. Negative voltage. What are you on? So, a couple digits here. Oh, we can get pretty sensitive though. Millivolts. Okay, so So 4 digits into the millivolts. My oscilloscope can do better than that. And the thing that that Wexo sent in can do better than that. That was Wexo, right? Yeah, I think that was Wexo that sent that in. Ooh, there's a nice little click when you do that from a relay. Oh, and you get a light behind the button. That's the on-off output button. That fan is very loud and very annoying. Breaker and killing the stream. Where's my computer plugged into? It is no longer plugged into that side panel. It's actually plugged in, I think it's plugged to the wall, and it's got a little backup power supply on it. So it wouldn't, I very specifically wired the shop when I did the rack mount so that I wouldn't be able to do that. If the circuit blows, it blows just for the stuff that's out on the bench. I used to have it plugged in like that. That fan is very annoying. That needs to be replaced with something that's not annoying. So DC and AC, we've got triggers, modify filter, control program and enter, call lock, what the hell? And then programmable power supply, negative positive track logic, supply select. This thing just floats here and threatens you with high voltage. This thing over on the end, it just doesn't do anything. We just don't, the power light isn't even on. Is there supposed to be a light back there? There's no power light on this thing. Dunno. We didn't see an LED, did we? Maybe there is. Why are you getting warm? Why is the power supply getting warm? Why is it throwing that much heat into its shell? There's a lot of capacitors inside of this thing that are now charged. Last calibrated in 1999. This thing had a long in-service life. I don't think these are from 1970s. I think this one is. How long did the 5006 exist? Because these seem to be newer devices. Welcome to linear power supplies. Yeah, this thing's crazy. I don't remember how to use these. The ones we used were these back here. The Agilent was the one we used typically. That I know how to use. This one I haven't had the opportunity. So our output is off. If I go to volts, I set it to 12 volts. No. What? I'll hold that down? No. Why'd it go? Huh? Get out of Inst ID. The button's stuck. So I got the 2 and then logic. This thing might not be functional. I'm starting to think this thing is not functional. Not exactly. Try to give you guys a good view here. There we go. Push to display limits. Push to slightly dim the display. Huh? This thing is broken as hell. No increments. Power's off. If I turn it on, that still only temporarily comes up. That lit up LED button is very cool. That's a cool thing. PS 5010 was produced from 1982 to 1995. I have a feeling these got upgraded through the years. I think they got incremental little upgrades. Because like this power supply looks like it's from the early 80s, and we found 1988 on one of the boards, and then this one looked like it was from the like the late 80s probably, or mid 80s, and then this board on the end said 1970s on the PCB. So this is 70s, 80s, all the hits from the 70s, 80s, and 90s on this soft rock station. Stick your multimeter leads into it and see if you're getting anything from the channels. I really don't want to. Let's be honest. I guess they are. It is right here. Fine, I'll do it. Fine, I'll do it. Take that to volts and turn it on. All right, Fluke, this is what you were built for, is sticking your nose in where it don't belong. You were designed for this shit. Especially these high voltage probes. Nothing on the negative supply. Nothing on the positive supply. Nothing on 5 volts, even though this does say 5 volts on it. I'm not getting good contact. No, these are banana plugs, so I should be getting good contact. Yeah, I'm not seeing any outputs. What? Turn output on. 4 point. Oh, that's out of whack. 4.95 volts. Okay, it's wavering between 4.9 and 5 volts, so that's actually pretty good. Oh my God, what have I done to my lead? And then these should be off, but who knows? Let's check. Yeah, they're not doing anything. These outputs aren't doing anything. So, like, I mean, it's partially working. It's just for some reason the interface is not doing its job. I don't think I plugged in anything wrong. Like, I have no control over it. Turn output off. I can't turn off the output. Oh, that's cool. It's not letting me turn it off. Hello? Power off. Oh boy, this thing is cooked. This power supply is cooked. Unless there's some other button that's stuck down. There we go. Button must have been stuck down. It's not exactly a matrix keypad, you know? Do you open up the machines before you give them any power to make sure there aren't any obvious faults? No, but this one I did, just because these have been sitting in a shed. So it was a good idea to do that, just to make sure. PCB calculator. Trace widths on IPC. I don't think, no, that's trace width calculator. Those are useful, but there's actually a simpler one that I used to use. Careful with those square buttons. The plastics tend to be tremendously brittle over the years. No, man, this is fine. These are not that brittle. These are kept out of the sun and in relatively good humidity. They're strong enough. The only problem is they're a little bit sticky. For that, I can take apart the keypad and clean them out. But the rubber is probably a little bit at the end of its life. It's okay. They spring back okay, but they kind of tend to stick a little bit. But they've definitely got like a rubber keypad behind them that's not pushing back as much. Probably because there's gunk in there from the years. So if I clean it out and I don't manage to break any of the rubber, which might be in a pretty fragile state, then I could probably get these to spring back properly. Supply select really messes with this thing. Yeah, something ain't right over here. .41. Those are, if you hold it down, you get the limits, but that voltage key is not helping me out. Yeah, I don't know. This supply is cooked. It can probably output proper voltages, but it's a little bit old. Well, yeah, I mean, that would clearly, the best way to clean it out isn't going to be to try to get at it from this side. The best way to clean it out is going to be to disassemble it, disassemble the whole front panel. And these things are hilariously easy to take apart. So that's going to be the best way to do it, and just use a little bit of soapy water. I have a stack of about 20 machines that I need to get to. Ah, jeez. Yeah, so I don't know. I'd have to explore. I mean, it's probably why you see in all these keypad designs, you see a mechanism by which the button itself gets sprung back separately from the rubber pad springing back. This, and I'm only speculating here, seems to be relying on the rubber to push it back into position. You want to have that, you know, both things have their own mechanism to spring it back. But again, I could take this thing apart, get into the backside of the keypad, and just give it a little soap. Probably there's a little tiny bit of gunk that got through the little gap there. But it's also possible that when I peel off the rubber, everything comes apart. I'm not going to do all that right now. Thank you very much. I'm not going to go through. We just took all this stuff apart. I'm not taking it apart again. All right. Anyway, that's been the TM 5006 for these past couple streams. Maybe let's power on the other one. I want to see what the other one does, if any of those are broken or not. I'll just stack it on top of this one. Oh, these things are heavy. Hold on. Give me one sec here. Well, so you see, let's theoretically, if you see equipment like this on the roadside, you could be looking at something that's so rare and valuable that you can't pass it up. But in the event you see something like this stuff, unfortunately, unless you're chasing nostalgia for a bygone era of electronics, if you're just plunking around with circuits, this stuff is useless. It is nigh on useless. Because for $20, you can get an arbitrary waveform generator kit that'll do just about the same. And since you're just a hobbyist, you don't care about it being ultra super certifiably accurate. Oh my God, the dog is just barking. All I'm hearing is whir. Okay, ready? 3, 2, 1, capacitor explosions. It is kind of nice to hear like a heavy fan spool up, go whir. It's kind of a cool thing to hear. I remember using this device in Drexel Labs. These things are cool. They've got this LED aesthetic to them. Pretty cool. Only one of these is registering as active. You guys can't really see that because it's not backlit, but there is text there. There is text there on the arbitrary waveform, on the ARB. Triangle, square wave, DC. It's got it all. External trigger, mode, continuous sweep, trigger AM. I can increment it, store, etc. These are in good shape though. Good stuff. Yeah, these are hard to use because you've only got so many characters on the display, so it's kind of hard to like make your way around it. Lots of input function though. You could flip from waveform to waveform. This thing, I'm not really sure if I ever use this thing. I don't even know what you would use a timer counter for. Like, what am I testing down here? Put that one to test. Put the increment up. Test ID. Got nothing. Whoa! That was fun. Whoa! Period, events duration, frequencies and ratios, trigger level for your input, auto trigger with a little bit of adjustment on that. You got these little lead hookups too, which is kind of cute.
Kind of cute. I think these were obsolete when we used them, though. They've been obsolete for quite some time. Like this entire module right here, all this thing is doing like the A to D that a microcontroller would do. So, my knees hurt. Yeah, measuring frequencies and counting frequencies and stuff like that. Basic stuff, huh? You got to use them in like one lab. All that money for one stupid little lab. This one really could use a backlight behind that screen. Frequency on. Frequency off. Yeah, well, okay, so the equipment works because it was made to be like bomb-proof. I mean, all the traces on these things are also far apart, and all the devices on them are not bottom-of-the-barrel devices. They've not been totally well kept, but not been thrown in a lake either. So they're pretty good, and they function all right. Okay, I don't know what kind of... Okay, that fan is releasing stuff into the atmosphere that I think Neri was unknown to science. So we're going to go ahead and turn that thing off. And I think I'm going to end the stream here before I get some kind of a horrible and infectious disease from whatever the hell was being thrown out of the back of those things. Probably should have cleaned that on retrospect. Suddenly realizing it personally, I probably should have cleaned out the back of the device where it was sitting in spider webs. Oops. So whatever I've released into the atmosphere here, I'm going to go deal with. But the sun's going down. I got to go walk my puppy because it is about time. It's about 5 o'clock. So I'm going to end it there. We're done with the Tektronic things until I can figure out where they're going to live. I don't know where they go. I don't know where they can go. They're certainly not going into that rack over there. They're probably going to go back into storage for a while unless I move shops. Yeah, I don't know what kind of stuff is back there. It's probably a dead mouse. But yeah, those are going to go back into storage because they're not that useful. I thought they would be a little bit more useful than they are. Even that like test setup part of the one is just like there's an A to D converter there, but it's not that good. Like it's like old. I can do everything that these things do with an Arduino. A Teensy 4 can do way more than these things can. It's insane where technology has gone. I could gut all of the rack mount stuff and build my own test equipment in there, or I could make them into modular synthesizer things, but they've got this giant fan in the back that makes all this noise. So if I gut them and make them into modular synthesizer stuff, that would be cool as hell. But I would have to replace the fans and get rid of the big transformer in the back and all that stuff. So it's a lot of work. Who knows what I'll want to do with these things going forward. I could try to sell them, but they're probably pennies on the dollar. But yeah, okay, anyway, that's the end of the stream. Listen, I got a couple social media things. I don't do a lot with it. I moved over to B-Sky with all the other electronics nerds, so you can find a thing to follow there with a bunch of electronics gurus, or, I don't know, just sub to me, because you love me. I love me. You should love me too. And then there's also a link to the Discord, which is pretty much where I'm spending most of my time. I'm always keeping an eye on the Discord and popping in and out of that. But in the meantime, I'm going to go touch grass. I suggest you do the same, and we'll catch up later. I'm going to be streaming tomorrow. We'll figure something out to do. It might just be another hashtag AutoCAD ad where we work on a circuit board a little bit. I'm sort of almost done figuring out where things go on the module testing module board. I want to get that thing built. I want to get that built. So we need to start laying down traces. Till then, I will catch you guys later. Do we raid into anybody? I don't think we raid into anybody, but I want to check to see who's around just in case. Okay, that didn't pull up Twitch at all. I'm just looking for Twitch here. Mute my audio. Looking down. Man, not a lot of people. It's like paleontologizing is one of the knowledge fellowship people that you guys might want to check out. But yeah, until then, I will catch you later. Have a good one. Yoink.